Good afternoon, everyone. Good afternoon, good evening, good night, good morning, depending on where you're joining from. How you all doing today? How is everyone doing today? Let me see. How are you all doing today? Just one word. How's the weekend been so far? How has the weekend been so far? Let me hear from you guys. I would like to know how your weekend has been so far, guys. Okay, great, awesome. Babashi, yeah, Michael. It's good to have you here. Okay, great. Okay, any other person? Let's use the chat. Use the chat, just type in how your weekend has been so far. In just one word, great, awesome, boring, stressful, work, load, whatever you want to use. All right, you can write anything you want, okay? Just drop it in the comment, okay? All right. We're gonna go ahead to start the session. Okay, we're still expecting more people to join, but we'll kickstart the session just the way it is. Okay, so I'm excited for you guys to be here today, and today's session is just gonna be about a 2 hour session for us to discuss, machine learning as a beginner and real life application. We're gonna look at a case study today. So you're going to enjoy yourself. That's something you need to know from the start. Okay, you're going to enjoy yourself. So if you've always been hearing about machine learning, machine learning, what is actually machine learning? What's the real life application of machine learning? Those are the things that we're going to look at in today's session. All right. So how many of us have we heard of machine learning before? Let me hear you. Let me see. Just put a one if you've tried out machine learning before, or if you understand what machine learning is all about. Just put a one in the chat if you've heard of. Okay, if you've heard of, and you've probably applied it one way or the other. Okay, Adisa also yes. All right, let's go. Okay, any other person? Any other person? If you've tried your hands on machine learning before, or if you've heard of it before, just put a one in the chat. Just type a one in the chat if this you've heard of it before. Okay. All right, fantastic. This is wonderful. Okay. All right. You can use the chat. Okay. So no, we're not going to give permission for people to, unmute themselves and all that. So we're going to be using the chat to have a conversation. Okay. So just type a one in the chat if you've heard of machine learning before. Okay. I will go ahead with the session. Okay, now that's exactly what we're going to talk about today, building our first machine learning project in today's session. So, obviously, this session is not going to make you an expert in machine learning, but it's going to give you a sound understanding of how to apply machine learning in a real life situation. That's exactly what we're going to talk about today. All right. So before we move ahead, okay, before we go ahead to the main session, okay, we need to talk about analytics and what we are setting out to achieve. So with Tenalytics is an educational technology firm with the goal to get more Africans into the tech space. Okay, the goal for us is to get more Africans into the tech space. So it's no more, no less. Okay, so if you're an African in Africa, or if you're an African in any place across the world in the diaspora, we will work with you till you get a job within the tech space. So we offer training programs across 8 specific career paths: data analytics, data science, business analysis, cybersecurity, financial and HR analytics, AI engineering, Scrum Master, business analysis, and so on. But today's session is going to be focused majorly on data science. So we're going to be looking at data science today. All right. And when I started data science, it was actually when I started, what made me interested in data science was I read an article from Forbes, okay, Forbes, and also World Economic Forum, and there were quite a number of articles at that time, okay, and every article that came out was, was saying that data science or data scientists was the sexiest job of the future. And obviously, when every reputable firm, reputable publication came out to say the same thing, that data science was the sexiest job of the future, I saw myself as, okay, do you know what? I need to learn this. I need to get started in this data journey. Do you understand? And that's exactly that's what made me interested in data science, okay? Made me start learning data science. And guess what? There are huge misconceptions about data science, a huge misconception. And I'm going to talk about that in today's session also. Okay, so that's what analytics is all about. Okay, and the goal for us is just to get more Africans into the tech space. So if you're an African, or you're in Nigeria, you're in Ghana, you're in Botswana, you're in Tanzania, you're in Kenya, you're in South Africa, you're anywhere in Africa, and you're looking to transition into the tech space, this is the platform to be on. Okay. And also, if you're an African outside the country, please, this is also the platform to be on because we'll work with you to get you started. Okay. So that's exactly what you need. Okay. And that's what we'll talk about. Now, who is the Femena April? Who is the person speaking with you? Why do I have an authority to talk about data science, data engineer, data science with you today? All right. So my experience has spanned quite a number of industry and also quite a number of roles within the data ecosystem. So I've worked as a data analyst, I've worked as a data scientist, I've also worked as a data engineer. So my experience has really spanned quite a number of roles within the data ecosystem. Okay. So currently what I do at the moment is more contracting. So I work with businesses in the UK, the US, and also now in Canada. I work with these businesses to deploy data analytics, data science initiative, and that's exactly what I do, helping them make sense of their data, helping them, all right, make the organization more data driven. Okay, so that's basically what I do at the moment, working with different organizations across the UK, US, and Canada. But prior to that, I've worked as a data engineer, data scientist, data analyst, business intelligence analyst, and so on. But you know the funny thing or the interesting thing about my career is I did economics. I read economics in university. I did economics in university. Okay. All right. I went to Lee City University in Ibadan. Okay. So I'm not nothing special to be honest with you. So I went to Lee City, studied economics. All right. And once I finished, I did not get a job as a tech professional. Okay. What I did, I got a job as a management consultant. So I did management consulting for about 4 years before I then transitioned into the tech space. So you find out that I don't have any technical background. Okay. I don't have a computer science background. I don't have any technical background. I did economics. My first job was in management consulting, which has nothing to do with tech. And I was able to transition into the tech space. So if at the moment you're looking to transition into the tech space and you don't have any experience, you don't know anything, all right, about the tech space, this is the platform to be on because the people that are going to be leading you are also in those, at one point in their own career, were in that same situation. We're in that same situation. Jedediah, please confirm you can hear me. I can see my microphone going up and down. Just trying
Yes,
to
I can hear
understand.
you.
All right, please respond to these people. I think they have issues with their microphone. All right, so you respond. I think two of them have dropped a message. Please just respond to them. All right. So I had no technical background, but I was able to transition. So you want to work with people that have been in your shoes before, all right, that have no technical background and we're able to transition and we're able to work with reputable firms across the world. Those are the kind of people you want to get yourself affiliated with. So that's exactly why we started analytics to say that, okay, do you know what? It took me about 2 years to transition from my non-technical background to a technical role. Okay. It took me 2 years to get my first job in the tech space. But now the key question we kept asking ourselves is, should it have taken us 2 years to get a job in the tech space? Now that we're in the tech space, should it take us 2 years to get a job? And the answer is a big no. All right. So it's a big no. It shouldn't take you 2 years to get a job in the tech space. But we'll talk about that extensively in today's session. But I am literally a testament to the work that you don't need any technical background for you to get started. Okay. You just need people to guide you, mentors to guide you on what to do, how to do it. And that's exactly what we're going to be talking about in today's session. So today's session, like I mentioned, is going to be for 2 hours maximum, ridiculously 2 hours. So I want you guys to follow me on this particular journey. We're going to do four things today, four things, just four, and we're done. Literally, just four things, and we are done for today. So number one is build your first machine learning model. That's the first thing we're going to do. Build our first machine learning model. So we're going to do that, and that's going to take the bigger chunk of today's session. Okay, with explanation, and after the session, you can actually do the same thing I have done in today's session. You can literally rinse and repeat the things I've done, and you'll be able to carry out the same. You'll be able to carry out the same things in once you're done with the session. Okay. All right. So moving on to the next thing. Number two is we'll discuss the pathway to becoming a data scientist and securing a job. All right. So the whole essence of you learning tech at the moment is not just for the fun of it. You also want to get a job. So the key question we would also be answering today is the pathway to becoming a data scientist and securing a job. Now, I would also talk about the Analytics Growth Internship Program, which has helped a ton of our people land jobs within the tech space. So the internship is something that you need to take a look at or to get invested in. Number four is we have a special offer for you, nobody else, nobody else, just you. All right. So these are the four things you're going to talk about today. So we're going to do the practical session, apply machine learning to a live case study. Number two, pathway to becoming a data scientist. Number three, the growth internship program. And number four, we have a special discount for you, nobody else. So you want to wait to the end of the session to hear everything that we're going to talk about in today's session. All right. So let's jump straight into the main session, machine learning. Okay. If you know what machine learning is, please drop a one in the chat. Let me see. If you know what machine learning is all about, drop a one. If you don't know, drop a zero in the chat. Let me see. Let's see the people that know and the people that don't know. It's not a crime if you don't know. That's the reason why we are in today's session. Okay. If you don't know, that's not a crime. That's literally why we are in today's session. So quite a number of people don't know what machine learning is all about, which is not bad. Okay, which is not a bad idea, which is not bad at all. Okay, and we'll discuss it extensively. We'll talk about it, and explain it in the best way I can. Okay. All right. So I usually like to, when I explain machine learning, I like to work with, institutions. Okay. One of the popular way to explain this for you to understand is by example, using examples. Okay. So now let's just assume this is, let me use somebody's name here. Let's say this is Dorcas. Okay. So Dorcas, give me a second. My pen is not working. Why is my pen not working? Give me a second. Okay, now it's working. Okay. All right, just give me a second. I'm trying to get a pen so I can leave and annotate on the screen and all that. Okay. All right. Why are you like this? Okay. All right. So I need to probably restart that particular application. Okay. Okay. Sorry, guys. Just give me a second. I'm trying to get up my pen. It was working just a second ago. Not sure what's happening now. Okay. So we're going to be talking about machine learning. Okay. We're going to be talking about machine learning in today's session. Okay. I don't know what's wrong with the pen. Okay. Jedediah, Jedediah, are you there?
Yes, I am.
Okay, give me a second. I just need to quickly, let me just drop off and come back 2 minutes maximum. So sorry guys, just give me 2 minutes. I need to write, so I don't know what's wrong with it. It's telling me to restart. So just give me 2 minutes, maximum 2 minutes to do all this, and I'll join the session back. Okay. So Jedediah, just 2 minutes, okay?
All right. Hello, everyone. Good evening. I trust that we are all having a fantastic day today. So, welcome once again to today's session. And in a moment, FMNA will be back to take on the session. For those of us who cannot listen, can't hear what or can't hear the sound, I left some instructions in the chat. You just have to look at the bottom of your screen. You see a headphone icon. Click on that and grant access to Zoom so you can hear the sound. So please, let's just get that sorted. And one more thing, the attendance form has been pasted as well in the chat. So please just take a moment to fill that out so you can get the recording of this session and all the other resources that are being used in this session. So please ensure that you fill that form so that you don't miss out on all of these resources. I thank you so much, everyone, and enjoy the rest of the session, which will continue in a moment. All right. I just dropped the attendance form a moment ago. So please, if you haven't filled it yet, just take 1 minute to fill that out so you'll be able to get all of the resources that are being used in this session, and so that we can also follow up and reach out to you. So please just take a minute to fill out the form, and we'll be back in a moment. All right. All right, great job, guys. Keep your form submissions coming in. So I'll just love for you to drop a 1 in the chat if you have filled out the form. Just drop a 1 in the chat if you have filled out the form. All right, fantastic. Cynthia, I can see this King Adiza, fantastic. I'd love to get responses from everyone else. Please just drop a message in the chat. Just say 1 if you have filled out the form. It's important that you fill it out so you can get access to the resources being used in this session. Excuse me. So as we are already aware, we'll be digging into a bit of machine learning in this session, and we'll be building a predictive model using Python. Before Efemena comes back on, let me just hear from you if you have had an exposure to Python before. Can you just drop Python in the chat box? Hello Ines. I'm just going to drop the form again so you can fill that out. Yes, so I was asking if you have used Python before, the programming language, if you've had an encounter using Python before, or you've heard something about Python before, you are aware of its relation to data science and machine learning. Just type Python in the chat box. Oh, fantastic. So we have Adiza, we have Cynthia, who have had some level of exposure to Python. And if this is going to be your first encounter using the programming language Python or anything related to machine learning, you can just type new. So we know some of us, I understand that some of us are new, and this might be our first experience actually writing codes and getting into the whole realm of data science, data analytics, and machine learning. Oh, so some of us feel scared when we heard the word Python. It might sound scary because we relate it to the snake Python, but then Python is actually a very interesting programming language to learn. It's one of the high-level programming languages and a very interesting one to learn. And the good thing with Python is that it's applied across many different scope of work, especially in the IT industry. And we'll be looking into how dynamic Python can be and how we'll be applying it as data scientists, building predictive models and seeing how they can be applied in real business case scenarios. So fantastic. I can see we have quite a number of people who have had experiences using Python, and we have a couple of people that are new. But nonetheless, FMNI is going to break everything down and it's going to take us from newbies or people who have not used Python before to becoming data scientists and professionals. Should I use the word professionals? Are we excited? Are we excited for that? All right, fantastic. I think FMNI is back and he can take on the session from here. Hi, Ivy.
All right. I needed you to unmute, sorry. Thank you very much. Apologies for that, guys. The system can just take it another tool from nowhere. Okay, so I'm just gonna go back to share my screen and where I left off. Okay, so sorry about that. Apologies once again. All right, so like I talked about machine learning, I wanted to go into explaining what machine learning is because quite a number of people on the call have heard of machine learning, but they don't know what machine learning is all about. So that's exactly what we're going to talk about, okay, in the next few minutes. Okay. So machine learning is a very interesting concept that, you know, something that we all do already, something that you know, but you just don't know that this is how it works. That's exactly what machine learning is. All right. So if I should ask you now, as a child, when you were growing up, okay, when you were growing up, okay, you went to school, you did not know ABC. They didn't give birth to you, and you knew ABC from scratch. You did not know that, okay? So what did you do? You had to go to school to learn it, okay? You had a teacher that was able to tell you when you see this letter, okay, this is letter E, okay? When you see this letter, this is letter B. When you see this letter, this is letter C. So over time, they trained you on this, and now you know it unconsciously. Anytime you see, even if you see the letter that is like this, okay, upside down, you know that this is letter A. If you see the letter like this, okay, you know that this is B. Okay, no matter how they want to turn the letter upside down, or no matter how they want to turn the alphabet, you know it. Do you understand? And that's exactly where you start. So once you understand how you personally, how you learn. So today you want to learn data science. You don't know data science, but you want to learn it. Okay. So you get trained on it and then you understand how it works. That's the same way it is. Okay. That's the same way machine learn. So the way you learn is the same way machine learns. Now, let me bring it home. Let me bring it home in the sense of like a business environment. Okay. So I was trying to use somebody, and I think I remember I was trying to use Dockers. Okay. So Dockers, I'm going to use you as an example for today's session. So let's say this is Dorcas, okay? Dorcas, all right, so this is Dorcas. Dorcas works as a compliance manager with a bank. Compliance, okay? Dorcas works as a compliance manager with, let's say, ABC Bank, okay? Now, Dorcas has, let's say she has a good years of experience. She has like almost 20 years of experience. 20 years of experience. She has been working in that bank for 20 years. So it means that Dorcas, so let's say, please use Aisha. No, I'll use your name for something else, okay? All right. So Doc, let's just use Dorcas for this. So Dorcas works as a compliance manager with ABC Bank. All right. And she has 20 years of experience. 20 years of experience. So these are the people that know the in and out of this particular bank. Anything that happens, she knows exactly what we're talking about. She knows it. She has seen it before. I mean, she has 20 years of industry experience in that particular bank. Now, she works in compliance, right? And because she works in compliance, it is easy for Dorcas to know what a fraudulent transaction is all about. Fraudulent transaction, fraud transaction, let's just say transaction. All right. So she knows immediately she sees the transaction, she knows that this is the fraudulent transaction. All right. Just by seeing it, she knows that okay, not very visible. Okay. Can you guys Jedediah, please can you see the writing very well? It looks clear for me. I'm not sure if that's the case for everybody.
Yeah, from my end, it looks clear as well.
Okay. All right. So just keep on going. I'll probably change it to white some as we go on. Okay. So Dorcas works as a compliance manager and she has 20 years of experience working as a compliance manager with that particular bank. So anytime she knows what a fraudulent transaction is all about. So anytime she sees a transaction, she can clearly say if it's fraudulent or not fraudulent. She knows immediately. All right. But obviously with ABC Bank has grown in 20 years. They've grown. So rather than having just maybe 2,000 customers that they started with, okay, so let's say initially they had 2,000 customers, but now over the years, that 2,000 customers has grown to 2 million, 2 million customer base, 2 million customers, okay, has grown to 2 million customers. Now, initially, Dorcas was the one that was, every transaction that comes in, okay, Dorcas will be the one to approve that transaction to say that, oh, this transaction is not fraudulent. This transaction is fraudulent. This transaction. So because there were just about 2,000 customers, okay, it's not all the 2,000 customers that will transact every day. So maybe in a day they can get like 500 transactions, 600 transactions, and so on. So Dorcas was the one in charge of approving those transactions. Well, over the years, customer has increased from 2,000 customers to 2 million customers. Okay. So it's difficult. It's not going to be, it's impossible for Dorcas to be able to approve customers, 2 million customers transaction is impossible. Let's say even not all the 2 million customers transact every day. Let's say even 200,000 out of the 2 million transact safely every day. It is impossible for Dorcas to approve every day by itself. Okay. All right. And it's also going to be difficult for the organization to what they call it, to recruit, like to recruit thousands of compliance managers. It's not going to make sense for them to, anytime customer base increases, they should go and hire more compliance people to approve transactions. It's not going to make any sense. Okay. So now the key thing is Dorcas has a wealth of experience. When she sees a transaction, she knows that the transaction is either fraudulent or not fraudulent. I mean, she has 20 solid years of experience doing this. So when she sees a transaction, she knows that the transaction is fraudulent or not fraudulent. Okay. Now, the interesting thing is customers increase. We're not dealing with 2,000 customers anymore. We're not dealing with like millions of customers. All right. Now, this experience, how can we bring this experience, into a machine? Okay, so rather than Dorcas being the one that would, all right, rather than Dorcas being the one that would approve the transaction, can we train a system? Can we train a machine that will be able to, that will be able to detect fraudulent transactions? Can we train a machine based on Dorcas's 20 years of experience? Can we train that machine, okay, to learn the way Dorcas has learned over the years? Can we train this machine to learn the way Dorcas has learned? Obviously, Dorcas will have learned by trial and error, okay? So when she started, she won't get it correctly at first. But over the years, she improved. She got better. She got better. Dorcas got better at what she was doing. Because that what did they say about being consistent about something, you get better. If you're consistent with something, you always get better. So because she has been doing this for years, obviously when she started, she wasn't very good. Over the years, she got better, and now she's now the go-to person. She's the compliance manager, and she's the one in charge of approving transactions and so on because of how good she has gotten over the years. So now, these years of experience, how can we bring it into a machine that will be able to do Dorcas's job? Okay, that will be able to do Dorcas's job as good as Dorcas would do it, if not better than the way Dorcas would do it. All right, and we create a machine that will be able to do the same thing, and that's where machine learning (ML) comes in. Okay, all right. So machine learning comes in to be able to replicate this experience that Dorcas have, in order for it to detect fraudulent transaction. And that's exactly how it works. So you see, human, which is currently Dorcas in this situation, we are limited. All right. We are limited in the sense that, 2,000 customers, I can handle 2,000 customers efficiently. That's not a problem at all. Okay. I can do it one person, even though it's week in, week out. Even if I hire 2 people, it's not too bad. Do you understand? Well, now, the moment you start to scale, the business starts to scale, okay, and you now get to like 2 million customers, it becomes difficult for you to rely on humans to approve all these transactions. Okay, it becomes very difficult because if you needed, like, let's say you needed 5 people to approve 2,000 customers, how many people do you think you would need to approve 2 million customers? Now, if you now increase to like 10 million customers, you need to keep recruiting more people that will be approving transactions. Okay, and it's very difficult for you to achieve that. Okay, so in order for you to avoid human intervention and all that because of our limitation, our personal limitation, that's where what gave birth to machine learning. Okay, how can we convert these years of experience into a system that will be able to do that same thing that the human used to do before, which is approving transaction? So now, if Dorcas is not there now, the machine will be able to look at the transaction and approve or reject a transaction based on Dorcas's experience in the past. So the machine now knows the way Dorcas used to prove, the way Dorcas would have, looked at the transaction, the machine would have seen that, understand that, learned it, and then also go ahead to the approving transaction. So you see, that's exactly how it works. And this is how machine learning works. Okay. So now this machine learning can now be divided into two. We won't talk much about that in today's session because we're just trying to get started with machine learning and all that. So we have supervised, okay, and unsupervised. Okay. All right. So we have supervised and non-supervised. Just the way it is pronounced. That's basically what it means. So, it's not like you over here, there is a mentor. Okay. All right. There is mentor, there is guidance, there is a guide. Okay. All right. There's a guide, there's a mentor, there's something that will tell the machine this is correct, this is wrong, this is correct, this is wrong. Just like if you're training your child now on ABC, or now ABC. Oh, ABC. We are pronounce it A for apple, B for ball, C for cat. Now, if the child decides to say that B for cat, you can easily tell the child this is wrong. This is B for ball. That's the supervised machine learning. So there is guidance. There's a guide to telling the machine this is right and this is wrong. Okay? But unsupervised, okay? No guidance. Okay? Zero guidance. There's nobody guiding the machine. So the machine basically is learning on its own. Okay. The machine is learning by itself. Okay. So it's learning by itself. So that's the unsupervised aspect. So it's trying to find out things by itself. It's trying to decode things by itself. That's the unsupervised aspect. Okay. So supervised, you have guidance. Okay. And unsupervised, you don't have, there's no guide. Okay. There's no guidance, basically. That's what it is. So that's machine learning. So the things that you do on a day-to-day basis can be replicated through machine learning. So, and there are quite a number of areas that this can be applied to, which is forecasting, okay, forecasting, predictive modeling, all right, and so on and so forth. So we'll talk about that in today's session, all right? So if you have any question at any point in time, please just drop the questions in the chat and I'll try my best to answer this question. So that's exactly what machine learning is, okay? So if you understand what machine learning is all about now, just drop a one in the chat real quick. Okay, if you understand what machine learning is all about now, drop a one in the chat. Let me see. Okay. All right, keep it coming. Okay. All right, fantastic. So now let's take a look at a live case study that we're going to be using, or we're going to be using in today's session, the practical case study for today's session. Okay. For today's session. So let's go ahead to do that real quick. So I'm going to go to my browser, all right, and I'll be using Google Colab for today's session. I'll be using Google Colab, all right. So for today's session, you might not be able to follow alongside with me, all right. All you need to do is just listen. All you need to do is listen. That's all you need to do. So you might not be able to code alongside with me for today's session, but all you need to do is listen. Just listen. Okay, so not to take too much time, and also for you to also understand. So when you're watching this video all over again, it starts to make more sense. Okay, so all you need to do is go to your browser. I'm going to start the process all over again. Go to any browser. I use Google Chrome. Then go to Google Colab. Type in Google Colab, like to collaborate. Google Colab. Sorry, I'm not typing Google very well. Google Colab. All right. So once you type in Google Colab, you see the first link there. Welcome to Collaboratory. So that's what we're going to be using. All right. So this is Python. This is where we start to introduce you to Python for machine learning. Okay. So well, now click on New Notebook. You'll see this pop-up will come out. Click on New Notebook. So Google Colab is free. It's free of charge. You don't need to pay anything, no subscription, nothing. It's free. The only thing that you need is a Gmail account. That's all you need, just a Gmail account. So once you type in Google Colab, if you don't have an account, it will tell you to create a Gmail account. If you have an existing Gmail account, please go ahead to use your Gmail account. It's free of charge, no subscription, nothing. Okay, so let's go ahead to today's session. All right, let's go ahead with what we're going to be doing in today's session. So I'm going to zoom in a bit. Okay. All right. So now we're going to start off. I'm just going to go straight to the case study. All right. So the first thing we're going to do, step one, okay, like every other data science project, step one, all right, is to load or import the data, import libraries, import libraries. Okay. Now, these libraries are what we call our tools, our work tools. As a data scientist, you have your work tools. So our libraries are like our work tools. The way a carpenter has their own work tools, they have the hammer, they have their chisel, they have their saw. That's their equipment. Those are their equipment. Okay. The same way a plumber has their own equipment, the same way an engineer, a road construction worker, the way you have, a chef, you want to cook, you have your pan, you have your pots, you have your different pots for different type of meals. Basically, those are their equipments, those are the utensils. So in data science, we have what we call libraries, our own equipment, okay, that we're going to use for data transformation, data wrangling, machine learning. We have our own tools. And these are the tools. So when we say import libraries, okay, it basically means that we are bringing in our arsenal. We are bringing in our tools, our equipment for us to start to work. Okay. So number one tool we're going to bring in The first tool we're going to bring in is for data processing. Okay. Tools for data pre-processing. Okay. So number one tool is import. We're going to import pandas. Okay. Pandas as PD. Okay. And the second one we're going to use for pre-processing. Okay. We'll talk about that I'll talk about that in a few seconds. Okay. The other one we're going to talk about is for data visualization. So different tools for different activity. Okay. Data visualization. All right. And that would be, we're going to be using two. So just because of time, I'm not going to be doing a lot of typing because we don't have too much time. All right. So for data visualization, we are going to be using Seaborn and Matplotlib. So those are the two equipments we're going to be using for data visualization. All right. Now for the last one, which is for data preprocessing and machine learning, the tools that we are going to work with is scikit-learn. Okay, so scikit-learn is the library for machine learning. So I will show you now in the scikit-learn. Okay, so scikit-learn, you'll see it here, scikit-learn machine learning in Python. Machine learning in Python. So that's exactly what we're going to be using. So this library is, like I said, Irisha, our equipment, our tools of work that we're going to be using to do the work. So if you have a bad chair, your chair is not, it makes a weird sound when you sit on it. All right, you call a carpenter. The carpenter will just bring the equipment and start to fix, start to hammer, start to remove the nails with whatever equipment that is, and so on. So we also, when we get data as a data scientist, you want to do machine learning, you bring in your tools, okay? So these are our tools of work that we're going to be using to do data preprocessing, data visualization, machine learning, and so on and so forth, okay? So I'm going to run that by pressing, you can just click here to run, click this play button to click here to run, and I'll create a code underneath, okay? So once it runs, it will give you like a tick mark. You see this green tick to tell you that that has been activated, that has been run, that has been ignited, whatever verb you want to use to classify to start. That has gone through, that has run. Okay. So now the next thing is to load our data sets. All right. The next thing is to load the data set. All right. I'm just going to bring a new cell so that I can have everything on top of the screen for you to see better. Okay, so the next step is to bring in the data. Okay, so just like an handyman, okay, you call them. Okay, my chair is not, or my TV is broken. Please, can you come over? Okay, well, the person won't just come over. The person will bring their equipment to your house first off. So that's what we did first. So we brought the equipment. So these are our equipment. We know we want to do machine learning. We want to do data processing. We want to do data visualization. So we have brought in our equipment. So the next thing is the television, okay? The thing that you want to work on. That's machine, that instrument that's broken, or that thing that you want to fix, or that thing that you want to work on, okay? So that's the next thing. So the data sets that we want to work on. So this is our work tools, okay? So what are we going to work on? We're going to work on a data set. So now data set is what we are going to bring in, okay? So now the good thing about Python and dual learning is it comes with free data sets. It comes with some free data sets, and that's what we are going to be using in today's session. So we're going to be using this data set called tips. Okay, that's why I said that once you get the material, you can replicate everything that we're doing in today's session. It's free. You're not paying for anything. All right. So what you can do is, sorry, I'm just going to say data sets to head. Okay. All right. And I'm going to run it. So now this is our data set. Okay. It's called tips. It's called tips. Okay. Not, okay. I will explain it in a few seconds. Okay. So SNS.load data set. So basically you are trying to load the data set. It's a free data set. You can use it for anything, for machine learning, data visualization, quite a number of things you can use it for. But today's class, we're going to use it for machine learning. Now, let me explain this data set. Let me explain the data set so you know exactly what it is. Okay. So, something I miss about the UK, one thing I miss the most, I used to live in the UK just under just a few months ago, I relocated to Canada, okay? And one interesting thing about the one major difference between UK and Canada, just to digress a little bit, is the tipping culture, tipping to tip, okay, to tip, okay. So now in UK, you barely have to tip. Only if you go to like a very good restaurant, then they could ask you for a tip, okay. So if you go to a good restaurant to go eat or to have fun with your friends, they would just ask you. You barely go to like an hangout place and they'll ask you for tip, okay. Like you buy food just in Nigeria. Nigeria does not have, a cultured way of collecting tip. Okay, it is Baba, anything for the boys, anything for the boys. Do you understand? Baba, anything for the weekend now, anything chief, anything for the weekend. That's the way they collect tip in Nigeria. Okay, but in the UK, you barely get that. You barely get it. Just if some very, fancy restaurant or some restaurant, you will get it, once in a while. All right. So tip was not something that we're used to. All right. But now relocating to Canada, okay. All right. Everything is tip. Like you must tip for everything. Every single thing that you're doing is tipping. All right. If you enter a cab, like literally, if you enter a cab, you are paying for the cab. The driver will still ask you for a tip. It's shocking. Okay. You go buy food, you're about to eat the food, you're asking for tip. Okay. So you're about to pay, they ask for tip. You go do anything. I mean anything. There is a POS coming asking for tip for you to drop either 10, 15, 20% tip. So the tipping culture here in Canada is a lot of it's a pandemic. There's a ticking pandemic in Canada. All right. So if you're looking to get into Canada, that's something you also need to mentally prepare for. You need to tip people. But I don't tip because it's optional. Okay. All right. I think I've only done it once, but don't tell anybody. This is between the two of us. Okay. All right. So now tipping. Now this is a restaurant. This data set is based on a restaurant. Okay. All right, restaurants. Okay, so this data set is based on restaurants, and they want to be able to predict who will tip or not. This is a Canadian restaurant. This is literally a Canadian restaurant, but they want to predict: are you going to tip us or are you not going to tip us? They want to be able to predict who will tip or who will not tip. That's exactly what they want to do. They want to predict who will tip or who will not tip. So you see here, all right, you see this is basically the sex, the gender of the customer that is paying, the gender of the customer that is paying. So you see this is a female customer, all right? Now, smoker, to confirm if the person smokes or the person doesn't smoke. So want to know, the smokers, do they tip more or do they tip less? Okay, those are the things that you're trying to find out using the data set. Okay, now the next thing is the day of the week. All right, the day of the week might also be a factor to the way people will tip when they come to our restaurants. So maybe on Friday, people after the day's week, they don't like to tip because they've worked hard that week. They just want to chill. And maybe on Sunday, or Saturday, that's when they tip more. Those are the things that is still assumption. We need the data to tell us exactly what will happen. Do you understand? All right, that's the day. Now the time. When people come for dinner, do they tip more? Do they tip less? When they come for lunch, when they come for breakfast, what's the situation? We need to know in order for us to predict who tips better, okay, or what the tip is going to look like. Now, the size of the people that come to eat, okay, how many people came to eat? Now, in this situation, 2 people came to eat, all right? In this situation, 3 people came to eat. In this situation, 3 people came to eat, and so on. Now, yeah, we have 4 people that came to eat in this situation. All right. Now the total bill is how much was their total, all the food they ate. Okay. How much did they pay for the food? So you see, this is $16.99. That's about $17. Here is $10.34, which is about $10.34, $21, and so on and so forth. Okay. So these are the features. Okay, that we have in the data set. So when you hear the word features in data science, okay, don't run away. Don't run away. Basically, it means coulombs. Okay. All right. It means coulombs. That's the best way for you, for beginners. That's the best way for you to understand. So you see, we have how many coulombs? Okay. We have 1, we have 2, we have 3, 4, 5, 6, and 7. We have 7 coulombs. It means we have 7 features in this data set. So when you see data science, I talking data science and they're using lingo. Oh, I need to do feature engineering. Or it's basically they're just dealing with coulombs. The coulombs in the data sets. That's what they're doing. So don't let them bubble you with big English. Don't worry. That's why we're here to explore, to tell you exactly what you need to learn. All right. So these are the features in the data set, which is columns. Please, features, columns. That's what it is. Okay. So those are the things that we're going to talk about in a few seconds. Okay. So now the key thing that we want to do in today's session is to predict who is going to tip and how much are they going to tip. Is that not interesting? A restaurant has the guts to say that we need to predict, we need to create a machine learning algorithm that will predict who will tip and how much they will tip. You see how invested these Canadian restaurants are in terms of tipping. Okay, all right, tipping pandemic. So let's go straight into it. Let's start the work, okay? Let's start the work without wasting too much time, okay? Anyways, if you come to Canada, that's what you would. That's something that you would get. It's a shock. It's a big shock, okay? So this is the data sets that we're working with. So let's go straight into what we are going to be doing in today's session. All right. So I'm going to add a text here, and I'm not going to do a lot of typing in today's session just because I'll do more of explanation than typing, okay? Because typing usually takes my time, and we just have a few time to be here. Okay, so before applying machine learning, okay, before applying machine learning to any particular data set, so to any data set, it's more or less like a routine work, okay? Based on your data set, there are certain things that you need to do, okay? All right, just the same way if your car is not working today, you go to the mechanic, to the mechanic, let me use my journey. You go to the mechanic to go and fix your car. They will do some routine checks. Do you have oil? Do you have water? Can it start? Do you need to push it to start? Is your battery, what's the level of your battery? There's certain things that they will do to just, to observe certain things. Eventually, they'll tell you that, oh, God, now carburetor don't spoil. The carburetor is not feeding water into the ignition, and the ignition they need to do testing first. Do you understand? So in data science also, when you get a data set, you need to test it, you need to look at it, you need to examine it. So that's the first thing that you're going to do. So let me put numbers there so you understand in the future when you get to see it. So number one, number two, okay, data preprocessing. Number two, okay. Number three is model selection. I'm going to talk about it somewhere. Like I said, I'm going to do more of talking than typing into this session. So you can understand. So people will not bubble you again. When you're looking at data science out there, you'll be like, oh, I understand this. If you may not taught me, if you may not taught me, I know these things. Okay. In just 1 hour, you see what you learn. Okay. Now, like I mentioned, when you get the data set, okay, there are certain steps you need to take. Number one is exploratory data analysis. Number one, the first thing you do is to explore the data. To explore the data. So that's what your mechanic will do when you bring your car. Okay, they will test: is your ignition working? All right, is the brake working? Is the accelerator working? Is your joystick working the way it should be working? So they'll do like a general test, and that's exploring all the features of the car: your gearbox, your brake, your transmission line, whatever it is that is in your car. They will test everything, your carburetor, your everything. So that's you also doing that in data analysis. That's exploration. You're exploring the data. You're trying to understand the data. That's what you're trying to do with exploratory data analysis. Now, number two is data preprocessing. All right. So data preprocessing just involves dealing with missing values. If you have missing value, if you have messy data, okay, if your data is messy or it's not structured in the right way, you're trying to structure it in the right way. That's exactly what data preprocessing is all about. So sometimes you would have dirty data. All right. Sometimes you have clean data that is not structured. So you need to restructure it. You need to make it look good. So that's the same thing with a car. So when you get your car there, you find out that they will start to things when they remove the oil, they'll clean the stuff, put it back to confirm if it is clean or it's not clean. They are doing all those works to examine what is happening in the car. Do you understand? And the next thing is to model selection. Model selection. So you want to apply machine learning to predict who will tip and how much they will tip. Who will tip and how much they will tip. So you need to predict, you need to call in your expert to come and do the predictions for you. Okay, that's exactly what machine learning. That's where you now start to apply your machine learning ML. So this at this point you start to apply your machine learning. Now the last part is training, testing, and evaluation. Training, testing, and evaluation. Okay, which is this is like the most important aspect. Okay, all right. This is the end of the road. Okay, to find out if it works. Okay, or if it doesn't work. Okay, so either it works or it doesn't work. So you see how the process starts from you exploring the data first to cleaning the data, ensuring that it is good for you to use it. Then the next thing is to apply your machine learning. Then you train, you test, and evaluate. Okay. So those are the 4 steps that we're going to look at in today's session. All right. 4 steps we're going to look at in today's session. All right. So without wasting too much time, okay, are you guys enjoying yourself? Let me see. Put a 1 in the chat if you're enjoying yourself. If you are understanding this thing so far, put a 1 in the chat. Okay. All right. You obviously you can't become an expert in just a few hours. Okay. All right. You can't become an expert in just a few hours, but you would actually learn a lot. Do you understand? You would learn something new that you can take on out there. Okay. So these are the processes we're going to take. Just the same way you carry your car to the mechanic I want to use accents, but the accent is not working. Okay. All right. So when you take your car to your mechanic, okay, they have some certain rules. There are some things they will do. Do you understand? And that's exactly what yours as a data scientist, when you receive data set, there are some set rules that you follow. Explore the data, transform the data or pre-process the data, apply your machine learning, then you train, you test, and evaluate. Okay. All right. So let's jump straight to the first thing that we have on the list, which is exploration, data exploration, which is, we have 3 types. We have 3 types in there. Let me explain that briefly before we move on to the work itself. So we have, when you're doing data exploration, we have univariate analysis, bivariate analysis, and multivariate analysis. Okay? 3 things. 3. Univariate, bivariate, and multivariate analysis. There are 3 of them. And I love saying these things because it makes you sound smart. It makes you sound like, though, you know what you're talking about. But you need to know what you're talking about also. So I'll explain it. So univariate, basically is talking about 1. Okay, let's just assume you're in a classroom. Let's assume you're in a classroom. Okay, you're in a classroom. Okay, you're in SS what? SS3. Okay, SS3. You're in SS3, and let's say there are about 20 people in this particular class. Okay, there are 20 people in this class. So now, and they wrote a test. Let's say all these 20 people wrote a test. Okay, they wrote a test. So now let's start with the first one, univariate analysis. Univariate analysis. This basically is looking at only one student amongst all the 20 students that you have. Okay, you're looking at just one student to say that this student, what did you score? You're only looking at just one student to say that you're trying to understand that one student, just that one student. Amongst 20 students you have in that classroom, you're only looking at one, and you're saying that, what did you score? What was your score? So let's say this person got a 10 over 10. So that's okay. Let's say 10 over 20. Let's say 10 over 20. So that's half mark. Okay. So you're just looking at just one person. You're looking at each student at a time, one after the other. So Paye, what did you get? I got 10. Kende, what did you get? I got 20. Adisa, what did you get? I got 40. Aishat, what did you get? I got this. So you're looking at one student at a time. You're trying to understand one student at a time. Now, when you now move into bivariate analysis, all right? What you're trying to do with when they say bi, it means 2, okay? Now you're looking at 2 students at the same time. So let's say there are 2 friends in the class. You're trying to say that, Aishat and Anastasia, what did you guys get? Oh, you now see Aisha to say, oh, Aisha, I got 15. All right. Anastasia will say, I got 18. Okay. So it basically means that Anastasia got more than iShot. So you're looking at two students together every time. All right, you're always trying to explore two students at the same time together, two students. All right, it could be, let me use another person, it could be Ayo and Ene. All right, to say, oh, Ayo, they are still in the same class, but you're looking at two students at a time rather than one. So univariate is going to look at one student at a time. Bivariate will look at two students at a time, two students together at a time. iShot and Ayo. iShot and anesthesia, then Ayo and Ene, and that's how you'll be looking at two students at a time in pairs, in pairs, in pairs. Okay, all right. Now the last one is multivariate, multivariate. Okay. Now with multivariate, we are dealing with three or more, So it's very easy. So even count it: univariate, one, uni one. Okay, bivariate, two. Okay, two, just two. So what's left? Three or more multivariate. So it's easy for you to count. So if you won't count it, univariate one, bivariate two, then multivariate, you see three there. Three or more. That's the best way for you to remember. Okay, so three or more. So you're dealing with three or more students. Three or more students to now see, okay, whose performance is the best amongst all the three of them. Okay, amongst three or more of the students. It could be 10 students, it could be all the students at the same time. Okay, it could be all the students at the same time, and you're trying to evaluate who got the highest score amongst 20 students that you have in those class. And that's exactly what you're doing with multivariate analysis. Okay, so univariate one, bivariate two, multivariate three or more. All right, and that's exactly what you're going to be doing. So now, how do you now apply this to the data sets? Very simple. That's what we're going to be doing. All right, so without wasting too much time, I'm just going to take this. All right, like I said, sorry, give me a second. This is the text. All right, so with univariate analysis, let's take a look at this. So with univariate analysis, we're looking at one column at a time, one column at a time, one column at a time. So remember, uni means one. Uni means one. Univariate means one feature at a time. That's what it means. Okay, so that's what univariate is saying. Univariate is saying examine one feature at a time. One feature at a time. Just like you're looking at a student, one student after the other. You, what did you get? You, what did you get? You, what did you get? You're trying to examine one student at a time. Okay, so you could just take a look at one feature. For example, it could be sex in this situation. So for sex, now we could ask that we can explore this to find out which customer, let me see, a very good example would be, a very good question for sex would be, what gender comes to the restaurant the most, okay? What gender or what sex in this situation, what sex comes to the, restaurant, the most? Okay, so that's looking at just one feature and you're trying to understand that one feature. So in terms of sex now, do we have more female or male customers that are coming to our restaurant? Do we have more male to female? So we're only looking at one column, all right? We're just looking at one feature, okay? We're looking at one feature to understand, do we have more male or female customers that are coming? We don't know just yet until we go ahead to do our analysis. Smokers, it could be smokers. Do we have more smokers than more non-smokers coming to the restaurant? Currently, we don't know. So you see, we're looking at just one column at a time. It could be day. What day of the week do we get the most customers? Is it Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday? Currently, we don't know. We need to explore. That's the exploration that we're talking about. Okay? Now, time. Do we come for dinner? Do people come more for dinner than lunch or breakfast? Currently, we don't know. We need to explore. Okay? Size. What's the typical size of people that come into our restaurants? Is it 2 people? Is it just 1 person? Is it 5 people? Is it 10 people? Currently, we don't know, but we need to explore. So you are looking at one feature at a time to understand what is happening in the data set. Okay? one feature at a time. It's just like your mechanic entry into your car. Okay. Let's say you want to test out the ignition. Okay. You want to test out the ignition. We test the ignition alone. It's just one. That's the one thing that is testing. Okay, your ignition not work. That's the first thing that you are seeing. If it goes, his hand moves from the ignition to the brake, to the what do you call it, to the gear stick, and finds out there's an issue with the gear stick, that's another feature in the car that is not working. The brake pad, if he pulls it up and down, another feature, is it working or is not working? Simple. So with univariate analysis, you're trying to figure out one after the other, what is happening in each of those features. Do we have more in terms of tip? How much do people tip? Do people tip more than $10, less than $20, whatever the case might be? We don't know, but we need to explore. Okay, that's the exploratory data analysis that you're hearing, that you've always been hearing. Okay, total bill. What's the average total bill? Okay, the people average bill here, average bill there. You don't know. We need to explore. So that's the features that we're talking about. That's the exploration that we want to do. So, like I said, I'm not going to do too much because that's not the focus of today's session. Okay. So I'm just going to do one feature engineering. I said feature engineering. One exploration data analysis. Okay. So I'm going to do the first one, which is, let's talk about gender. Okay. What sex? Okay. Come to the rest comes in more. Okay. So let's find out. So we have a column here, which is sex. Okay. So we have male and female. We're trying to find out what sex comes in more. Do we have more male customers than female customers? Do we have more female customers than male customers? We don't know. Let's explore. Okay. So I'm just gonna, like I said, I'm not gonna do too much of. Okay. So boom, boom. So let's explore. This is the code. Okay. I'm not teaching you coding today. I'm teaching you understanding. Okay. AI can teach you how to code. Don't worry. I'll teach you how to do that in a few seconds. All right. So what sex comes in the most? So we're looking at sex now. Just one feature, which is sex, which is one feature amongst all the. It's just like the 20 students in the class. You ignore every other student and you focus on just one student to say, what did you just get? You're always making noise in my class. And that will be, what did you get? Do you understand? That's exactly what you want to do. All right. So in this situation, even though there are how many columns there? There are 7 columns in there. We are ignoring all of them to say, all of you, we'll come back to you, but let's look at sex first. Do we have more male than female? Now we can clearly see using the pie charts that we have more male customers than female customers. The male customers account for 64.3% of the customers that come in. Can you see how the insight is coming in now? So all of you that said that, how do I analyze data? How do I come up with insight? This is how insight starts to generate from. This is how it starts to get generated. So we have 64% of our customers coming in, male customers, where the remaining 35% are female customers. You see how interesting data is. Data is one of the things that will get you addicted. I'm addicted to data. I love data. Okay, so that's something I need to I'm trying to disclose to you guys. So that's one feature. We could try another feature. Can anybody give me another feature? Let's see. Okay, let's try non-smokers. Smokers and non-smokers. I don't have enough time to go ahead to be asking, one after the other. But once you have the data set, you can try your hands on it, do the same thing I've done, and you'll be happy to see what you'll get from it. So let's try one more. Okay, do we have more non-smokers? Okay, do we have more smokers to non-smokers? To non-smokers. Okay, so let's take a look at this. Okay, and those are the same thing, copy and paste. Okay, and I'm just going to boom, let's run this. So now looking at this, we're just looking at one feature at a time. We're ignoring every other person. So we have left sex alone. We know that we have more male customers that come in than female. Now we're looking at smokers. Smokers, we have more non-smokers. We have 61% of non-smokers coming in, while the remaining 38 are smokers. Okay, so that's univariate analysis. Okay, you're looking at one feature and you're trying to understand that feature to the best of your ability. Just one. You're ignoring all of them, just one of them at a time. Okay. Now moving on to the next one, which is bivariate analysis. Okay. Can anybody tell me what bivariate analysis is? Can you guys remember? One, univariate is one, bivariate is what? How many? And what are you doing with bivariate? Can anybody remember bivariate? Bivariate. How many? Two. Let's go. I love that. DJ King's Kid. Let's go. That's fantastic. Two. You're giving me two features now. Bivariate is looking at one feature. Universe is looking at one feature. Okay. Bivariate is looking at two features. Now let's take a look at it. Okay. Data and ed. Data.ed. Two features. Now let's take a look at two features. Two features. Fantastic. You guys are awesome. All right. So now with bivariate, you're not looking at two features at the same time. Okay, two features at the same time. So now a very good example is, a very good example is sex and total bill. Sex and total bill. Two of these features together. I want to explore this together. We want to find out, what are we trying to find out with these two things together? Sex and total bill. So now we have male and female that come in. Okay, we know that we have more male than female customers. I mean, 64% of our customers are male customers. So they account for more. Okay, that makes sense. Now, but will they pay more? Will they pay more? Is their total bill more than the male or female? They more? Is it more? The male pay more than female. We honestly we don't know yet. A lot of guys can just come in and buy bottled water and leave. Okay. All right. Why the ladies will come in, two groups of girls, faster lifestyle. Okay, I want to eat, all you can, all you have over here. Do you understand? Let me eat all the food here, and that's it. Take all bills on me. Do you understand? So the ladies might actually be paying more, but we don't know. It's still an assumption. So in data, okay, we don't take assumption. We only deal with what the data is saying. We deal with what the data is saying. So let's take a look at it. Which of these genders actually has more total bill? Those are the things that you're not exploring. Two features. You see how we have now left one, and we're not going into two. To say that let's explore two features at a time. Two features at a time. Interesting. It's as simple as that. It's not as difficult. It's nothing too much. Okay. You see how we are moving on. All right. To two features. Now, which of this gender spends more money? Which of them are the big spenders? Okay. That's what we're trying to explore in the next part. Okay. So let's just quickly do it. Okay. All right. So I'm just going to write it here to say that what sex has the most total bill? Has the most, what am I writing? Most total bill. Okay, so let's go through that. That's a code for that, and I'm going to run it. Okay, and now you see, okay, maybe it's not so bad. Okay, maybe the guys actually pay more money. All right, the guys actually have more bills. They actually pay more. Okay, so now we've seen that we have more male customers coming and they actually pay more. But now the other question is, do they tip more? Okay, do they tip more? You don't know. Guys might actually come in, pay a lot of money for their food, but hide on their feast in terms of tipping. Women might actually tip more. But now you're looking at two features again in that same data set. So what features would you be looking at in that situation? You'll be looking at sex, okay, and tip. Okay, so we've left total bill and now we're looking at tip. Okay, so you see how exactly. So you're looking at two features at a time. You're playing, you're trying to find insights, you're trying to get insight from the data. All right. So when you're talking to if you're doing this for a business, you're not telling them exactly what you've observed from the data that you've gotten. That's exactly where data science gets very interesting because you will see things that other people cannot see. Okay, that's the interesting thing. You will see things that other people cannot see. With the same two eyes where God give us, you will see more. All right, because you know how to drill data, you know how to work with data. So if you want to find out who tips more, is it smokers or non-smokers? You also need to know. So what would you be looking at? You'll be looking at that smokers and tip. Do they tip more? You want to find out what's the total bill of non-smokers and the total tip of non-smokers. Okay, what time of the day do they tip more? You are looking at these two again. All right, do people tip more in dinner than in supper? or it's a supper, that in lunch or breakfast. All right. The size of people also and tip. Let's take a look at another very interesting one in a few seconds. Okay. So let's take a look at another one. I'm doing two for each one of them so that you understand. Okay. So there are quite a number of questions that you can answer with the data sets. Okay. So the next one I'm going to be looking at is the next one I'm going to look at is there a relationship, okay, between total bill and tip? Okay. Okay, let's look at this. This is a very interesting one. Okay. Is there a relationship between total bill and tip? Is there a relationship between total bill and tip? So if the more the total bill, the people pay more. If there's a less total bill, the people pay more. If there is, what's this? What's the, we want to know. If you come and spend $200, I want to know how much you will tip me. Do you understand? Will you tip me more or you will tip me less? So let's visualize it. Then I will let you guys decide what you see in that particular aspect. Okay. So let's take a look. Sorry. What's that? All right, fantastic. This is it here. All right, so relationship between total bill and tip. What can you guys see here? What can you guys see here? Okay, what can you guys see here? Looking at this visualization, I know it's not, if you're not very good data science, data professional, you may not know, but what can you guys see from this? Someone said that if the data set was for a restaurant in Lagos, we honestly won't need data analysis to know the gender that spends more. You'll be surprised. That's assumption. That's a big, big assumption. And that's what we don't do with data analysis. That's what we don't do with data science. You don't assume just because based on what you think, it's not the same thing that really happens. Trust me, you'll be surprised. All right. Guys can actually go in to buy bottled water. They'll buy fancy things for the girls, but they'll buy bottled water and that's it. Okay, so Aisha has a question. Why does the analysis produce answers in visualization form and not in tabular or column form? Fantastic questions. Now, which one would you understand better, visualization or a table? Okay, so a visualization speaks. They say picture speaks in what? 1,000 words. Pictures speaks 1,000 words. That's the same thing with visualization. All right, visualization will tell you everything that you know just by looking at it. Just imagine if you use a table to visualize male and female, how much did they spend? You need to look at it. You need to look at the numbers. You need to use your head to think. Is 13,000 greater than 14,000? You need to look at it. Sometimes if there's no comma, you'll not find out that you'll not be looking at it. Okay, 14,000, 1, 2, 3. You need to think. It involves it takes a bit more time to process column and tabular data. All right, it teaches you a bit more time to visualize. But if you see a bar chart like this, male is bigger than female, it's clear. That's why you say pictures work more than 1,000 words. That's why you use a lot of visualization as a data scientist. You will use a lot of visualization. Can somebody say a lot? A lot of visualization. All right. We'll talk about that, okay? But that's exactly why you need to use visualizations, okay? Aisha, I hope I answered your question. Let me see. How do you interpret the scatter plot? Let me now talk about that. Let me talk about that. Now, we talk about the scatter plot, okay? So wanted to find out total bill and tip. Is there a relationship there? Do people pay more when they pay more? Do people tip more when they pay more? Do people tip less when they pay more? Whatever the case might be. Let's take a look at the visualization. So this is visualizing now. Let me explain. This is very interesting. Okay, very interesting insights that you see here. All right. So over here we have tip. Okay. Over here on the x-axis we have tip. Oh, that's a big, big knot. All right. Over here, just gonna get a small pen. All right. So over here we have total bill. This is the total bill people will pay in the restaurant when they come in, and this is what they tip. Okay, so we're trying to compare the two of them, two features at the same time. This is what we call bivariate analysis. Just trying to reaffirm that to you so you remember. So this is total bill, and this is what they tip. This is what they pay for bill, and this is what they tip at the end. Okay, so you see, it started from 0 all the way to, let's say, 55 maximum. We have here is 55, here is 50. Okay, Tipping is starting from 0 all the way to like 10. Let's say 10. Okay, let's stop at 10. Let's stop at 10 and 50. All right. So now you see here, obviously, this is the total bill, 10. Okay. Okay. So people that have a total bill of 10, like if you finish eating and your total bill is about $10, you would normally tip about $2. Okay. Okay. You would normally tip about $2. Okay. On average, about $2. Okay. As the total bill increases, you'll find out that as the total bill starts to increase, tipping will start to increase. Okay, all right. So let's take a very good example. Let's take a look at this person here, or this person, or any of these two guys. Okay, all right. So let's take a look at them. The total bill, what was the total bill? Let's take it down all the way to the end. The total bill is about, let's say, $48. Let's say about $48. Now, this person tipped as high as almost $10. Pardon my line, it might not be very straight. Let's say about $9. Person tipped about $9. Okay? The person tipped about $9, paid about $48 in tip, total bill, but tipped about $9 in tip. This person paid about $51, about 50, let's say about roughly about $51 for total bill, but tipped about $10 in tip. Do you understand? So these are like so it's basically telling you that the more people spend, the more the tip. The more people spend, the more the tip. It's simple as that. The more people spend, the more they're likely going to tip. So it means that in this situation now, all right, this is a good insight for me as a restaurant owner, if I own a restaurant, I can easily use this to attract more people. Okay, so I can design strategies to say that spend up to a certain limit, and meal is free for the next person, some kind of discount or something that will get people to try to attain that high amount. Because I know that if they get to that high amount, they will likely tip more. They will likely tip more. Do you understand? So you now start to design strategies around how can we get more people to come in, pay more money, and they're to translate to more tip. So the more money you spend, the more you tip. That's what this is saying. All right, that's what the visualization, that's what the data is saying. So we are the oracle now. We're trying to read what the data said. Okay. But obviously, there are some what we call outliers. There are what we call outliers, meaning that people that don't conform to the normal. Okay, people that don't conform to the normal. So if, take for example, you're a guy, this is an example to most guys. Give me one in the chat if this has happened to you. It has happened to me before. So you go to a restaurant, okay? You don't just you maybe just want to buy water and just wait for your friend. Okay, you just want to wait, but the waiter that came, one very fine lady, fine lady comes. All right, the bottle water is about 200 naira. About 200 naira. Okay, you are paying small. Looking at this person here. Okay, this guy here. This person is paying less than. It's paying about maybe give or take maybe like $7. Okay, but he's tipping almost as high as what he has paid in terms of total bill. Something negated, something that's not normal. That's against the normal way of doing things. So probably in this situation, this guy bought bottled water and said, okay, I'm just going to drink water or just have a glass of wine and I'll be on my way home. Which the person that keeps to save him was not like, look, ML, we'll talk about that. Don't worry. Okay. So when you this kind of situation, this is what we call an outlier. So normally people that buy less, people that have a total bill, small total bill, they usually tip less because they didn't spend so much. So why would they tip so much? It's normal. That's something that you should think about. Okay. But in this situation, this person spent $7, but is able to tip about $5, almost as high as his total bill. Okay. Person will come drink Gary, guys go buy 500 tea. That's just the way it is. Do you understand? That's what we call an outlier, someone that doesn't go with the norm. Okay. But we also have big spenders that are doing the same thing. So you see this big spender over here, this person spent about $45. That's a give or take about $45. But his tip is just above, shy above $2. It's just about, let's say about $2.5. Person just tipping about $2.5, but spent about $45. So these are what we call outliers in our data sets. Okay, these are what we refer to as outliers. So you see how you've learned so much in today's session, you guys. Okay, see what you've learned in just a few hours of just playing around with a data set, a natural data set. So, you know, you have outliers. This guy also is an outlier, okay, spending about almost $33 and is just tipping under just about $1. Okay, it's not normal. Okay, that's what is an outlier. Okay, so there are different ways you can deal with outliers in a data set. This is where you now start to do your data pre-processing. Okay, because outliers will distort your machine learning algorithm, might distort your machine learning algorithm. Okay, so that's exactly what we're talking about. Okay, so somebody said, please, can you kindly talk about the outliers again? Briefly in 2 seconds, I'm just going to do that. So outliers are people, not people, data points that doesn't confirm, okay, that don't confirm with the normal. Okay, so take for example this particular person here. The normal trend is the normal trend based on the data set. The normal trend is the more you spend, the more your total bill, the more your tip. The more your total bill. So if you go there and you spend $50 like or $55 like this guy here, you would likely tip more. You will tip more. Okay? You will tip more. So that's the normal thing. The more your total bill, the more your tip. All right. But now you see this guy here, this person has, less, what just about $7 in total bill, but this person is tipping about $5. That's an outlier because normally if you buy less, if your total bill is less, your tip is less. That's what the visualization has told us. The lesser your total bill, the lesser your tip. But you see this person here is tipping more. Okay? He's tipping more. Someone that doesn't conform to the trend exactly. That's an outlier. So it doesn't have to be only small, it could be also large in the sense that see this particular guy here, see this person here, see this person here. These are somewhat sort of outliers. They are outliers. This guy here is an outlier because he's spending about $33, but he's tipping about $1. Okay. So the normal trend is the more your total bill, the more your tip. So in this situation, this guy is not conforming to it. Okay. All right. And that's basically what we refer to as an outlier. So you see, this is bivariate analysis. You're looking at two features and you're trying to understand those two features together. Okay, two features together. Okay, all right. So we're not going to, because of time. I know I said I'm going to just do 2 hours, so I'm not going to take too much. I'm not going to do more than that. All right. So I'm just going to go straight to the machine learning aspect here, just because we don't have time anymore. I hope you guys have enjoyed yourself so far. Okay. All right. So let's go straight into the machine learning aspect. So let me bring in a text. So I'm going to come here and type in. Okay. So yeah, I'm going to say machine learning. Okay. All right. So with machine learning, it's going to be very interesting. Okay. So I'm going to bring in my data. I'm just going to visualize, show you the data again. Okay. All right. And let's go ahead. Let's go. Let's go. So these are our data sets. Okay. This is our data set. So one, the first thing you need to know, we're not going to do something too technical. Okay. I don't want to do something too technical. So when you have a data set, machines don't understand text. They don't understand text. They don't understand. So computers, binary, 0 and 1. They understand numbers, but they don't understand text. Okay? They don't understand text. So in data science, we usually use what we call categorical data. Categorical. Okay? We call them categorical data sets. Basically, it's text. Basically, text category. So basically, when they say categorical, it's in group. Okay? There are different categories. Okay? So category 1, category 2, whatever the case might be. So in this situation now, sex is a categorical data set in the sense that it is female or male. There are two categories. It's either you're a female or you're a male. That's the two categories that we have here. Okay. Another category. Okay. Smokers or non-smokers. No, yes. It's either you're a smoker or you're not a smoker. Also, the day of the week, Sunday, Monday, Tuesday, Wednesday, these are different categories of the week. Is that you ate on Monday or you ate on Tuesday or whatever the case might be. Time, also another category, dinner, lunch. These are all categories. So ML does not, does not work with categorical data. It doesn't work with categorical data. So you will need to find a way to transform categorical data into numerical data. Okay, numerical data. Okay, so that's basically what we're going to do. That's the first thing we're going to do. Because we want to apply machine learning, we know machine learning doesn't work with text or categorical data. Okay, so we're going to convert this text into numerical data. So we're going to do that in the next few seconds. Okay, all right. So that's step one. That's the first thing we're going to do. That's the first thing that we are going to do. So now, all I'll do now is I'll just get the, label encoder, and I'll do that real quick. So over here, I'm going to say transform categorical data into numerical. Okay. So we're going to use a library called label encoder. So that's what we're going to use. I'm not going to bore you with the whole process of how it works, but anyways, just know we're trying to convert categorical into numerical. That's what we're trying to do. So I'm going to show you the data set. I'll show you now what it looks like. So data.add, data.add, open and close the brackets, and that's it. So you see now, rather than male and female, rather than having male and female sex, male and female, now we have it as 0 and 1. So 0 for female, 1 for male. 0 for female, 1 for male. So you can see it by the first two characters that you have there. So you see the first person here, all right? 0 and 1. So looking at this one also, you see it here, female and male. So we have transformed categorical data into numerical data. Okay, isn't that the work of GetDummy? So I don't like to use, so there are two types. I do want to go too technical, but because of the question, I'm just going to go a little bit. So we have one hot encoding, okay? All right, and we have label encoder. So label encoder is better to use, okay? So label encoder is what I have used. You see it here, label encoder, okay? So I used label encoder because it's not going to create new columns for you. One hot encoding, there's a problem with that. There's something we call dimensionality reduction, okay? Dimensionality, so there's a rule of thumb when you're working with data, not to increase the number of features that you have, the number of columns that you have. One hot encoding will do that, okay? Would create new columns for you. So you want to stay away. You don't want to try this first. You don't want to go with this. So usually I like to work with label encoder because it's better. Okay, it's doing the same work, but it's not creating more features for you. So for that person to ask that question, he knows a bit of data science. So if you don't know, don't worry, just relax. All I've done is transform categorical to numerical. So if you look at smoker and non-smoker, no or yes, you see no is 0. Okay, day of the week, they will give them numbers. Sunday will be 2, Monday will be 3, so on and so forth. That's basically the numbers. So time of dinner also, rather than dinner, lunch, breakfast, it would be 1, 2, 3. It would be numbers. Okay. So rule one, data science. You want to apply your machine learning. Okay. Machine learning doesn't work with text. It works with what? Numbers. So if you have text in your data set or categorical data, like I mentioned, you need to convert it into numerical data. Okay, you need to convert it into numerical data, and that's exactly what we just did. So you see, there's no text, no categorical data in our data set now. No category, no text in our data set. We have purely numbers, correct? So number 2 is to separate the targets and features. Let's do that real quick, okay? All right. So the next thing you're going to do is to separate. Okay, So what we're going to do now is, you see, in our data set, let me explain this in a brief seconds. In our data set, we want to predict people that will tip, correct? We want to train a machine to say that, tell me who will tip and how much they will tip. Okay, who will tip and how much they will tip. That's what we want to find out. Okay, so this is the key thing that we want to. This is what we want to find out. Okay, now let me use a better explanation. Let me bring it home for everybody. All right. So let's say you have a child. Okay, you are trying to teach the child A, B, C, D, and E. So you know that A is for apple. You wrote it on the board, on the blackboard, okay? Or you have a book, okay? You write it in the book, you write it on the blackboard, you've written it, and you say B for ball, C for cat, D for dog, and E for egg, okay? We have it in there, okay? Now, when you're training the child, A for apple, B for ball, C for cat, D for dog, E for egg, correct? The child can see, and once they see A and apple, they see the word, they can tell that, oh, A is for apple, B for ball, and so on and so forth. But now, if you don't want to test the child, if you want to test the child, what would you do? Would you keep the answer there? Would you keep the answer in there? It's still the same text. It's still the same A, B, C, D, and E. But would you keep this text in there? Would you keep the answers in there? You won't keep the answers. I'm correct. Is that correct? You won't keep the answers there. You won't keep the answers in there. All right. What would you do? You get, something that would clean up the answer. Okay. You clean up the answer and say that, you know what? Let me see if this child would be able to guess the ABC to E without the answers being there. All right. Adisa, go ahead. Sorry, Adisa, I've used your name a lot today, but just take it the way it is. So Adisa, tell me ABC, what is A without the answer being there? Would you be able to tell me? I want to know if you'll be able to get it. So that's the same thing. Even in the exam, imagine you go for an exam, okay, and the answers are there in front of you. You write the answer. Do you understand? So the first thing you need to do is to remove this guy. Remove it. So the answer, remove the answer. This guy, this is what you want to predict. So the first thing you need to, the second thing, so the first thing we did was to convert categorical to numerical. Okay. The second thing is, you see this thing that we want to predict. If we leave it inside, okay, the machine is not stupid. The machine will see the answer. The machine can see the answer. It will give you the answer back. And it will be 100%. You will get 100%. Okay. You'll get 100%. It's just like you go to an exam and the answer is, they give you question and they're giving you answer at the same time. What will you do? You write the answer. You're not dumb. You won't say that, oh, I don't want to look at the answer. They literally provided it for you to say question and answer is in front of you. Write the answer. You write the correct answer. So what we want to do is we want to test if this machine, if it gets sense. Should you get sense? You feel drum yourself. Do you understand? You feel drum yourself. That's exactly what we want to do. And you do it by yourself. If the answers are not there, then you predict by yourself. That's literally what machine learning is all about. But we'll get there gradually. So the first thing we've done now, remove this, what we call the label. Okay? Remove the label. Okay? That's exactly what this code has done for us. So this code will remove the label, remove this thing, this guy here, this tip, remove it. Remove the answer. Remove the answer from the question. Remove the answer from the question. Okay? Let's go ahead. So when you remove the answer, we could now find out if this machine learning, if it gets sense, or if it no get sense. All right. So let's remove the answer. Let's remove the answer real quick. So you see, and I have something now, what I call plain data, which is the plain data, just plain data. Okay, I call it plain data. So you see it here. I'll use .ed so I don't print out something else. It's too much. Okay. So .ed, you see that there is no tip anymore. We have total bill, we have the sex, we have the smoker, we have the day of the week, we have the time, and we have the size of people. No tip, no answer in this question. Okay, see the answer. We kept the answer inside this place. The answer is here, label. So if I print label, so if I say print label, Okay, let's test it out. So you see, this is it. This is the tip. These are all the tip. These are my answers. So when you have a question, when you go to the exam, you have question. When you have answering, what they call that thing again, answering booklets or no, marking templates or whatever they call it back in the days. So there's a question, all right, but there's an answer, there's a marking scheme or marking whatever they call it, the answers to the question. Okay, so that's exactly what we've done. We created a question and we have our marking. So mark to say that okay, machine learning, you got this one correct. Machine learning, you got this one correct. Machine learning, you got this one wrong. Machine learning, do you understand? So what we want to do. So we've created a sweet and juicy question for the machine learning algorithm. All right. And we have our answers. We have the answers. But that's that, oh yeah, machine learning, they say you will replace human. You will take over my job. Okay. I want to test you now. Can you guess? Not guess, can you predict? Okay. Who will tip and how much they will tip? That's exactly what we want to do. So we have the question and we have the answer. Okay. So now what are we going to do? The next thing is that's the main work that we're going to do. So we're going to divide it into training and testing. Okay, we're not going to change it into training and testing, and that's the next thing we're going to do. I'm going to explain training and testing in a few seconds. Okay, all right. So I'll explain it in a few seconds. So we have train and test. There's something we call train and test when you are doing machine learning. There's something we call train and test. Train and test. Okay, it's just like humans. I mean, we all went to university, we all went to school. So you won't go to school for 3 months to do what? To learn. To learn. They'll give you the booklets. They'll give you books, all the Ugosigo. They'll give you all the books. They'll give you books to go and learn. Go and learn. You go to classes, you do midnight classes, you do prep sessions, you do tutorial sessions, you do as much as possible to do what? To learn. So that learning space for you is what we call the training phase for the machine learning algorithm. Okay, the way you are learning, the way you go to school, you carry torchlight, you carry lamp to go and read, to learn, to sit down to learn. Okay, it's the training that we're talking about. That's the machine learning too. Even though you don't see it, we carry lantern, all right, and go and learn, and go and look at it, and go and do his work. They say that they're going to. They say there's going to be an exam in the next 3 months. Okay, I need to start learning. I need to start training myself now. That's exactly what is happening in machine learning also. So you need to train the algorithm. You need to train it. You need to, it has, the way you, before you go for an exam, you have 3 months of learning. When you go to classes, you come back from classes, you write, you do first test, second test, you do all those things. They have 3 months of you to learn before you now write the final exam. Okay? So that's exactly what we are doing here. So we will train the algorithm first. We need to train it. It needs to see, it needs to train, it needs to understand the data, it needs to understand correlation, it needs to understand everything. All right. Then once you finish training, we'll now say that, okay, do you know what? If we give you another set of questions, okay, would you be able to answer? It's as simple as that. It's as simple as that. It's like you also learning A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, W, or multiplication table. All right. When you finish learning it, you now come to class. Yeah, recite the seven times table. Okay, 7 times 1 and 7. You start to repeat it. Okay, but you need to train first. You need to see it. You need to understand. That's exactly what is happening in the training phase. All right. So after training, after you finish going to school for 3 months, they need to assess you. That do you really know this thing? Did you, even though you come, we saw that you came to class, you wrote your first test, you marked your attendance, you did all those things, all right? We will still, at the end of the day, we still want to test you. Do you know it? You sabi am? Do you know it? That's exactly what we're trying to find out. And that's where testing comes in. So even though you testing, yes, you are doing well, you come to class, that's not enough. We still need to test you to know that, okay, you are going to get the right thing. So that's the training and the testing that we're talking about. The training and the testing that we're talking about. But we're using the same data. We're going to use the same data. Okay? The same data that we used is what we're going to use. So this data, all right, we are going to split it into two parts. Okay? We're going to split the data into two parts. This same data that we've been talking about, we'll split it into two parts. So usually we use 70%. Okay. Some people usually the normal split rate is 70% for training the data. Okay, we use 70% of the data to train the algorithm. Now we'll use the remaining 30% to test if it is working or it is not working. Okay, in this situation now you see my test size is 0.2. That's 20%. Okay, so I'm using 20% and 80% for my training. So my test size to test, I'm using 20%. For my training, I'm using 80%. So 80% of my data, I'll use it to train it. Okay, where go for prep, go and carry candle, come and read, come and do this. I'll use 80% of that data to train it. All right. Then when you finish, I'm now saying, okay, you've used 80% of the data to train, okay? Now let me test you. Let me test you on 20%. 20% that the machine learning algorithm has not seen. It has not seen before in his life. Okay. Now let me test you. Would you be able to do it? That's exactly what we're trying to achieve. Okay. So this is where we call the training and testing. So the data sets, the same data sets, okay, we are going to divide it into two parts. One part for training, the second part for testing. Okay. The first part for train, I'm going to take 70% of the data to train the algorithm, the machine learning algorithm. And I'm going to use the remaining 30% to assess. You sabi am, abi you no sabi am. Are you working or you're not working? Do you understand? That's exactly what we are talking about. So for my own case, I'm using 20%, which is 0.2. 0.2 is equivalent, okay, to 20%. Okay. So for my test set, if it is 20% out of 100%, what will remain? It will remain 80%. Okay. Should make sense. Abiko makes sense. Do you understand or you don't understand? Let me see. Put the one in the chat. Let me see if you understand. Let's see. Let me see. All right. So, all right, sorry. We understand. Let's go. So that's the training split. Test, training, and testing. So we train first, then we test. Train first, then test. Train, then test. Train, test. Okay. So this is the way you're going to go about it. Okay. So you have done that already. All right. So for the first one, I'm going to do. All right. I'm going to use two algorithms. Okay. I think I'll use one just because we don't have enough time anymore. I will just use the linear regression first off, but we also have the support vector regressor. Now, these things are what we call the machine learning algorithm. Okay, it's statistics. So that's why they tell you statistics is important in data science. So you see the algorithms, they call them algorithm, but the back end is just statistics. Okay, it's literally just statistics. Okay, it's interesting to know what's happening behind it. It's just like a car. You know, you drive your car every day, but if they ask you, sit down, what is the mechanics behind how your car moves from point A to point B? You likely struggle. You really don't know how the fuel transforms into energy and then moves the car. You really don't know. Why can't you put water inside your car and your car will move? Why? Is it not liquid? Okay, if it's a viscous you're looking for, okay, put engine oil inside or put vegetable oil. Why can't another equipment, why can't another liquid move your car from one point to the other point? Okay, you really don't know how that car works. But can you drive the car? Yes. If they say you should race your friend from here to Ore, you will do it. Okay, you can walk with your car, you can move it from gear one to gear two to gear three and move very quickly. You can do that easily. All right. Will it be, is it more, it will be definitely more interesting if you know how your car works. Meaning that if it breaks down, you know how to fix it real quick. And that's the beauty of you understanding statistics in data science. Now, you can use the algorithm without knowing what is happening back end, just like your car. You don't know what is happening back end, well, you can use it easily. Okay? Anybody can apply it. I mean, even anybody, when I say anybody, a 2-year-old boy, if you tell the person this is how you will use it, they can use it. Okay? All right. But if you don't know what's happening at the back end, it's likely going to be a bit, it's better if you know what's happening. Let me just put it that way. Just like a car. If you know how your car works, you know how to improve it, you know how to get it better. Okay, you have people that fix their car, that model their car to the way they want it to look because they understand the car. Okay, so that's the same to machine learning algorithm. So this algorithm is statistics that is happening back end. Okay, it's statistics that is doing the work, the machine learning. Okay, the learning and all that. So if you know how it works, it's good for you. If you don't know, you can still apply it. It's not going to say you don't know how to apply me, so I'm not going to work for you. It doesn't work that way. Okay. So it will be good if you understand how it works, but if you don't know how to work, you don't know how it works, you can still apply it. That's just the way it is. All right. So I'm going to be using linear regression, and I'll also be using the support vector regressor. These are what we call machine learning algorithms. Don't get it twisted. Love is a beautiful thing. Okay. It's if a man again. Okay, so I'm going to be using linear regression and support. So SVR stands for support vector regressor. That's what it stands for. Now let's apply. Let's apply. Okay, let's apply the linear regressor first off. Okay, so let's apply, and I will take it one step at a time for you to understand what we've done. So when you're trying to do this by yourself, it will make more sense. Now let's take a look at this. Okay, let me print the result. Let me print the result. Okay, I'll print the result, and voila. Now, let me explain what I've done. Okay, so we're going to be using linear regression and support vector regressor. These are machine learning algorithms, like I mentioned earlier. Now, let's talk about this. So you see this, the first thing that we did here was to train the data sets. That training that we talked about, go to school, go and learn, do 3 months of classes. That's exactly what is happening here. This machine learning algorithm, I've told it, even though it is just happening in one line, even though this is just one line of code, okay, this machine learning is going to go to school, is going to on Candle and be working back in. It's going to be doing a lot of work trying to understand, customer, sex and gender, sex and total bill and this, total bill and that, and it's trying to answer the question by itself. It's learning it's learning the way you go to school and you want to write your IELTS for JAPA, the way you go and study. It's the way it's studying also. It's trying to understand the data, okay, and it's self-assessing itself, okay, to understand how the data works. So this is where we call it. This is the training phase. This is training. So it is training at this point in time. It is training as hard as possible to understand, to know how to work it out, okay. Now, this is now where you now test it. This is where you test to say that, okay, you finished training, 3 months of work. Go and do, you finished training, you've done your training. Now, let me test you. All right. So you give it another, the data set that it has not seen before, another set of data that it has not seen before. Oh, yeah. Like I remember, if you remember, what we're using 80-20, 80% to train. Okay. 80% to train, and the remaining 20% for what? For testing. Okay, for testing. So it has seen 80% of the data sets. It has seen it, it has played with it, it has understood it, it knows it in and out. Okay, but now I will now give it the remaining 20% to say that, oh yeah, come and test. Let me test you on this. That's exactly what you have here. So you see it's LR, which is linear regression predict, equals to predict the X test. Predict it. Yeah, this X test, the 20% I kept aside for you to test you on. Come and test it. Come and try. Let me see if you will get it. Come and try. You think say you feel replace my job, Abby? You can't replace my job. Come and try it. Come and do it. Come and do it. Oh. So you're testing me now to say that. Are you going to make sense? Do you know it, Abby? You don't know it. Okay? That's exactly what is happening at this point in time. Now we move into measuring. We need to measure. Did you get it correctly or not? It's just the same way you write the exam. And at the end of the day, there's a teacher that will now mark it. The marking scheme. There's a marking scheme. And now say, oh, you got this correctly. You missed this. You got this. You got this. You missed it. Evaluation. You now start to evaluate. At the end of the day, you're not saying, oh, I got 60 in my exam. Oh, fantastic. That's great. I got 55. Average. I need to do better next semester. Okay. Oh, I got 75. I got 80. The way you evaluate, the way you are evaluated when you write an exam is the same way we are evaluating this machine learning algorithm. Nobody passed evaluation. We must evaluate you. Okay? All right, even though you're a machine learning algorithm, we still need to evaluate you to know if you know it or you don't know it. It's as simple as that. So that's the evaluation that we are talking about. You get me? Okay. Now let's evaluate. So this is the evaluation metrics that we are using. So we are using the MSE. Okay, for you guys that don't know statistics just yet, don't worry, you'll get to know it. These are things that are very easy to understand. MSE means measure of squared error. Measure of squared error. So error, they're trying to focus on error. Is it making error? Okay, so you're trying to see on average, what is the average error it makes? Okay, what is the average error it makes? So that's basically what we are trying to do with the MSE, mean squared error. Now the R squared is a very easy one to understand. So the R squared is basically looking at zero. The answer is usually between 0 to 1. Okay, mean 0 to 1. Indicating the best way for you to understand this is, let me get my pen. I don't know where that moved away. Okay, all right. So it moves away from 0 to 1, and you're trying to understand. So if it is 0, it means he did a bad job. He did a terrible job. Okay. If you get 0, it's just like the way you get 0. If you get 0, you've done a terrible job. Okay. 0 means bad. 1 means awesome, great. It means fantastic. You've done a fantastic job. Now, the moment you go from 0 to 1, okay, so anything between 0 to 1. So if you get 0.2, it's not very great. That's basically you got 20 out of 100. It's not great, okay? If you got 0.5, that's average, 0.5, that's 50 over 100. If you got 0.8, that's good. I mean, it's 80%. You got 80% correct. You got 80% of your predictions correct. Okay, so from 0 to 1, that's how you range it. So now looking at this RMS, R squared, it is 0.44. So what do you think about 0.44? That's about 40%. That's got 40 out of 100, 44 out of 100. So what do you guys think? Is this good? Is this okay? Is this a good one that we can use? Do you think we can use this algorithm? So the R squared is 0.44. This right here is about 69%. Okay, we'll talk more about that. Okay, but this right here, let's use the L squared. All right. So currently this is sitting at 44%, which is 44 over 100. So what does this mean to you? Is this good, or is this average? Is this bad? What would you say? Let me see. Is this good, terrible, or bad? Okay. All right. Keep it coming. Keep it coming. Use the chart. Let's use the chart quickly. Use the chart. Let me see. Let me see. Below average, bad. It's definitely below average. Definitely below average. Okay. So these are the things that you are going to work with. Okay. Those are the things you are going to work with. So bad, obviously bad. And this is where you now start to test out other algorithms. You start to test out other ones because currently linear regressor is not doing a good job. It's not doing a good job. All right. In Yoruba parlance, we're going to say Olodo ni linear regressor. Looking at the assessments, linear regression is not doing very well. Okay. So what we're going to do is also test out the next one. Let's see. That's where I'm going to call it today, anyways. Okay. That's where I'm going to call it today. I'm just going to call out the next one real quick. Okay. And let's try out the support vector regressor. Okay. And let's test it. Let's evaluate. Did it make sense? Is it able to do better than the regressor, than linear regression? Let's find out. So now with this here, you can see the R squared for this. The R squared is about 57%. Okay, it's about 57%, while the MSE is about 54%. Okay, so when you compare this against this, the R squared usually is better. I won't say it's better, but it's more is widely more used than MSC is used, but it is subject. It is, I don't want to go too technical, but it is not the most accurate. Okay, it's not the most. It can be actually be biased in some sense. In some time, sometimes it can actually be biased. It is used. Okay, all right, but the reason why you have multiple evaluation techniques is because they are not all perfect. So you need to use all of them together to evaluate them. Okay. All right. So you have MSc, you have R squared, you have RMSc, you have so many of them, okay, that you can use to evaluate. You have your MAD, you have your MAE. There are so many of them, okay, that you can actually use to assess. Okay. But today's session we're using the R squared, which is ranging between 0 and 1, okay, which is easy for people to understand. Same thing with the MSc. It's also be easy for people to understand because it is percentage. If you say something is 63%, you know that, oh, it's good. It's not too bad. Okay. So looking at this one, this is 57%, which is stand. So the support vector regressor is, in terms of the R squared, is about 57%. Okay. So it's still, obviously there's a big error of about what? 43%. There's a huge error of about 43%. So if you use this algorithm, okay, it will get about, out of 100, it will get 53, 57 correct, it will miss 47, 43. That's a huge that's a huge one. Okay, so that's a very, very basic way of explaining this, so you understand a lot better, a lot better. So basically, that is machine learning. Okay, and that's like you don't just test out 2 algorithms, you test out several to see the best performing it, the best performing algorithm. Okay, so based on the best one, you can always fine tune it. That's what we call hyperparameter tuning. So you start to tune it to make it look good, to make it look better. You can introduce feature engineering where you can start to add more features to see if it will become better or worse. That's what you now start to do as a data scientist. So a lot of work will be put in order for you to predict what will happen. Hyperparameter tuning. So you have it here. Hyper parameter, okay? Parameter, not parameter, okay? All right, so hyperparameter tuning. So you see it here, when you're training a machine learning model, each data set and model needs different type of hyperparameters, which in fact, it's not to go to technical, don't get headache. For a beginner, just start to understand it first, then you get to understand it. So basically, you can tune your data set, you can tune the algorithm, you can tune things to make it look better, to try to see if it will be better. Okay, so not to waste too much time, becoming a data scientist is not as difficult as you think it is. Okay, it's actually one of the best things that would happen to you. Like I said, as a data scientist, I have a wealth of experience now, cutting across different industries, different different parts. I've worked with organizations that I never felt I could actually work with. All right, just because I'm able to look at the data set first off, and I'm able to understand the data set, and I'm able to generate insights from the data set. And I can also go ahead to predict what will happen. That's what makes data science very interesting. And you see, that's what our people have gone on to do. Okay. So you see, Tony here currently works as a benefit analyst working with the NHS, full sponsorship. And we also have Oluwatosin that got a job with one of the reputable credit card organizations in financial institutions in Nigeria, in the UK, also working as a fraud analyst. Now let's listen to what Tosin does in just about a few seconds. I'm going to play his video so you see. Jedediah, please confirm if you can hear the audio. Just confirm answer, please. Okay.
Hello, my name is Oluwatosin
Yes, I
Ogunleye.
can.
With the August DA cohort with Tenalytics. I just got a job as a fraud analyst. So my role as a fraud analyst is to investigate and prevent fraud on credit cards. I got this job after I joined Tenalytics. The mentorship session, the CV review sessions, these sessions were very, very helpful in me getting this role. And I had an interview prep as well. All these were highly instrumental in me getting the job. And I'm really grateful for Tenalytics. Thank you.
All right, you can see that, yeah? And that's exactly what you get from the training program. Okay, you will get to learn data science and not just
Hello, my name is Samara Chiokam, and I am here to thank Tenalytics for.
need to post that. Okay, so you see all those are testimonials. Okay, we have close to over 2,000 people who have gotten jobs in the tech space, and those are the things. And you'll see from today's session, you would have learned a lot. Okay, you would have learned a lot. So imagine you spend the next 3 months immersing yourself in the learning process of data science. Trust me, you'll be a hot cake when you get out there in the job space. So what do you need to learn to become a data scientist in the next 10 minutes? Number one, learn statistics, because that's what you rely on. It's just, like I said, if you understand the way your car works, okay, you can make it better. Okay, that's exactly what statistics will do for you. So we'll teach you statistics, not the way you've learned when you're in secondary school or university. You'll learn it in a more instructive way, in a more business in tune way, for you to understand how it can be applied to the business. So something like the mean, median, mode, how can it be applied to an actual business? You would learn all that, okay? Now, moving on to the next, you will learn Excel and Tableau for descriptive, diagnostic, and predictive analytics. So you use Excel and Tableau, okay, like the data analyst, but you take it one step further to be able to predict using Excel and Tableau. So you'll be able to do predictions and all that using Excel and Tableau. Then you would also learn SQL. SQL is fundamental. It's a fundamental skill of a data scientist. So SQL is the next thing you learn. You would also learn Python and GitHub, for programming and version control. But once you learn programming and Python, we use Python for today's session. That's what we use. So after Python and GitHub, we move into machine learning. So this is where you now start to apply supervised and unsupervised. You work on projects, you deploy, and so on. Then after that, you move into computer vision and natural language processing. So these are key specializations that we have in the data science space itself. So computer vision and natural language processing. And once you're done, you become a master data scientist. Now, you would also get additional materials, or you get additional how to use AI as a data scientist. So you work with tools like ChatGPT and GitHub Copilot for programming, for analysis, for decoding, and so on. So this is the run through you're going to go through, from statistics to using Excel and Tableau for exploratory, for descriptive, diagnostic, and predictive analytics. You move into SQL, Python for GitHub. You move into machine learning. You move into computer vision and natural language processing. And then you also work on master data scientist. You now become a master data scientist. Now, moving on, the type of roles you could actually get on once you go through the training program. You could work as a data scientist, you could work as a data analyst, sales analyst, supply chain analyst, fraud analyst, just like, Oluwatosin I played earlier, pricing analyst, market research analyst, logistics analyst, and so much more. Like for myself, I've worked as a business systems analyst. I've worked as a, what other role involves data science, logistics analyst. Okay, I've worked as a supply chain analyst. So these are roles that you can actually take on once you complete the training program. So you have a huge spectrum of roles that you can actually apply to once you complete the training program. Now, the good thing also is the training program comes with internship. It comes with internship. Okay, for 1 month, full-on internship where you're going to be working on real-life case studies. All right, you'll be deploying your machine learning algorithms. You'll be learning how to use these things in a real-life environment, and that's exactly what you get to work with. Now, why should you train with us? It's very simple. You will spend the last 1 hour, 2 hours with us today, and you see that the way you learn with us is absolutely different from what you would do any other place. Okay, so why should you train with us? Number one, we have phenomenal achievements. We have helped over 2,000 people transition into the tech space in the last 4 years. 2,000. And we have testimonials. And that's one of the testimonials I showed with you. I'll still show you more as we go on into today's session. Number two is industry standard facilitators like myself. Okay, I want to believe I've done a good job today. So we want to learn data science from people that actually have industry experience and people that have used it in real life, and they can explain to you how it works. Okay, that's exactly what you're going to get. Number three is the blended training curriculum, and I'll expatiate on that in the next few seconds. So we have the live classes. You have live classes that you would get every weekend. You have the classes every weekend. And you have self-paced materials that would help you learn to your own pace. Okay, that will make you learn at your own pace to get started. Now, the last but not the least, is the tailored session, mentorship session. So now this tailored session involves CV review. We'll help you review your CV. Okay. Number two is we'll work on your LinkedIn, optimize your LinkedIn to get a wider reach of recruiters and employers across the world. We'll also help you with Upwork optimization. We'll teach you how to navigate the job market. So where to apply for jobs, where to apply for remote jobs, where to, and so on, all the things that you need, where to apply for. There's something we call the Eden Job Market. We'll discuss all that in the training program, which is part of what you'll be paying for. All right. Now, in job and interview preparation, once you get an interview, if you have a good CV, you have a good LinkedIn profile, you know how to navigate the job boards and all that, you would get interviews. And once you get interviews, would help you in achieving that. Okay, would help you prepare you for the interview. Number 6 is recommendation letter. So once you get a job and you need recommendation letter, we'll provide you with recommendation and reference letter to back up your application process. So we have mentorship sessions where we bring in experts from the industry to come and talk to you again on different aspects of data science, data engineering, the data ecosystem essentially. We have all the job support to get you started on the job. So once you get a job, the key thing is just to get a job. We'll support you even after the training program. Now, moving on, we have a training program starting on the 8th of June, 2024. So if you're looking to get it started, start now. This is the best time for you to get started. And that's exactly what we're going to be talking about. So we have the training program starting on the 8th of June, 2024, the data science training program. And we still have an amazing offer for you if you're looking to get it started. We have an amazing offer for you if you also want to learn data science and you want to transition into data science. This is the training program for you. This is the training program for you. So we have that discount. So rather than you paying $750, $625, $730, or $1,125 or 900,000 naira, we have this huge 20% discount for you to get started. So currently it's $600 if you're in the US, £500 if you're in the UK, 580 euros if you're anywhere in Europe, or 900 Canadian dollars, or 720 naira, 720,000 naira. Now, the good thing about the discounted amount is you can pay in 2 installments. So rather than you paying this money at once, you have the chance to pay in 2 installments. So the first installment, which is the first payment you see here, this is what qualifies you to be in class. This is what gives you opportunity to be in class. Okay, so all you need to do is pay $400 if you're in the US, then you balance $200 1 month into the training program. So the balance comes 1 month. So it's as flexible as possible to get you started. So if you have the $400, all you need to pay now is $400 to get you started. £350 for you to, £350, £150 balance 1 month into training program, 400 euros for you to get registered, or 180 euros for you to balance 1 month's time. The same thing with the guys in Canada, 600 to register, 300 to balance 1 month. Now, if you're in Nigeria, $500, 500,000 naira for you to get started, then 220 1 month into the training program. So this is the beauty of it. You're going to be learning from, people that have industry experience and they've been doing this for quite a while. So if you want to make payments, it's as simple as clicking on the link. So once you click on the link, the main stack.enroll Tenalytics, main stack, okay? So my colleagues so for Ghana CDs, you can actually once you click on that link, the main stack.me enroll Tenalytics. I'm going to copy it again and paste it in the chat. Okay. All right. So once you click on this link in the chat, it will take you to this page. Even if you're in Ghana, you're in whatever country you are. Okay. Once you click on the link, it's going to show you your price. It will show you the one that works for you. Okay. What currency works for you. If you're in Ghana, I think it's Naira that you can pay to do the conversion and all that for you. Okay. All right. So what you want to do is you want to make payments. If you're interested in making payment, all you need to do is click on the link and scroll all the way down. You'll see direct transfer. Okay. So you want to do a direct transfer. So if you want to do a pound transfer, this is the account number. If you want to do a USD account number, if you're in US, you want to do a transfer, you can use that. And you could also do a transfer Canadian dollars. And euros, you could actually do a transfer. So that's if you want to do a direct transfer. In the same vein, you could also just pay online, which is easier and faster for you. All right. All you need to do is click on Full Stack Data Science, click on Full Stack Data Science. Okay. And That's it. Once you click on full stack, you see here, full stack data science. Click on that, and it's going to open up in a new tab. Okay. And then it is, you see 900 Canadian dollars. That's what I have because of the region where I am. Okay. So this price here, it will be based on your region. Okay. So that is minus 900 Canadian dollars, but I don't need to pay 900. Okay. I don't need to pay 900 to secure my discount. All I need to pay now is $600. That's all I need to pay the discount, $600. Okay, so I'll put in $600 and boom, proceed to pay, and you are good to go. You're good to go. So once you put that, all you need to do is just put in the amount and you're good to go. Make your payment, put in your card details, and so on. Okay, so I'm going to walk you through again. You could do a direct transfer, or you could actually pay online. Okay, full stack data science. Click on that, get started. So somebody's saying, waiting patiently for 8th of June. I can't wait to start. Can I pay the balance in Naira? If you're paid in one currency, it's going to be difficult for you to pay your balance in Naira. Okay, so if you're paid initially in USD, you must balance in USD. It's usually like that. So it's just so that we're getting the right value for it. Okay. So for Canadian dollars, all I need to do is type in the money. If it's in pounds, all you need to pay for guys in pounds, you need to pay only 350 pounds to get started. Okay. For the guys in euros, all you need to pay is the first payment here you see on the screen. Take a screenshot. All you need to do for the first payment is to click this first payment and you are good to go. So somebody's asking what day of the week now we have training programs. Okay. So we have training programs every Saturday. Okay. Every Saturday. Okay. All right. Every Saturday. So live classes happens every Saturday. All right. So now we try to keep it to the guys in Africa. Okay. Slash the guys in Europe. Okay. Europe. Okay, so that's inclusive of the UK and so on. So we have this time, that will be 10 a.m. okay, in the morning to okay. So that's the time. It will be the live classes on Saturday. African time will be 10 a.m. okay, 10 a.m. to 2 p.m. West African time. Okay. So we also have the evening session, which is tailored for the guys in the US/Canada. Okay. All right. So for these guys, okay, it's gonna be 10 a.m. in the morning also, okay, to 2 p.m. Mountain Standard Time. So if you're in the US or in Canada, this is the time you are going to work with. Okay, this is the time you're going to work with. So if you're also in Nigeria and you want to work with this time, that will be in the evening for you. That's going to be in the evening for you. So that's likely going to be around 5 p.m. okay, to about 9 p.m. Okay. All right, and that works for you. Depending on obviously there's the time glitches and all that, 1 hour minus 1 hour, whatever the time works for you. So all you need to look at is the Mountain Standard Time. That will be 10 a.m. to 2 p.m. Mountain Standard Time. Okay. So that's basically the way it works. Okay. Somebody's asking what happens to the people that can't afford the training program. Unfortunately, there's nothing we can do. Okay. All right, nothing we can do. Let me show you what you gain access to once you make payment. Let me show you what you gain access to. Then we call it a day. All right. I'm gonna show you the platform real quick. You're gonna get access to two platforms, two wonderful platforms. Okay. Okay, so first thing, once you make payment today, you would gain access to the LMS. So we have our own LMS that stores all the things that we're going to work with. So you see, this is the full stack data science program. So this is the self-paced materials that I talked about earlier. Okay, so you have access to self-paced materials from Excel to Excel and statistics to forecasting to Tableau to SQL. These are all self-paced materials that will allow you to practice better. Okay, so now using Excel, for example, even if you're a beginner, it starts from the resume. Sorry, from the basic areas, okay, which is introduction to Excel, for example. It takes you through that particular aspect, which is everything that you need to know. So you start from the beginning, which is what is the cell, what is the range, what is how to write text in Excel. It starts from that basic. So even if you're a beginner, you are in the right place because we're taking you into that consideration. Okay, so we're taking into consideration and we're going to work with you to get it done. So we start with that basic requirement. What's a shortcut? How to use shortcut? How to write? How to type? How to edit? All those things are discussed in the materials. Then we also have self-referencing, which we'll also talk about, and it's also practical. Okay, it's also practical, walking you through what self-referencing is. So you're never for once going to be on your own. So the way you have your self-paced material, you also have live classes. So it's double-edged sword. So you have live classes, you have your live classes, and I'm going to show you that now in the next 2 seconds. Okay, so you have the classes, okay? So you have the live classes, and I'm going to show you the guys that just started. So we have the full stack data science, which is the guy that in the May cohort. Okay, so you see it here, data science. Give it a second. It's trying to load. Okay, so you see it here, full stack data science 2405. I'm going to click on classwork. Okay, and you see their live classes. Everything is stored here. Okay, everything is stored here. So you see their live classes. Excel week one. Okay. So you have week one drop-in session, mentorship session. So these are the mentorship session. I'm going to show you the mentorship session in just a few seconds. Okay, so you see, we have this mentorship sessions where we bring in experts from the industry come speak to you. Okay, so this is one of the mentorship sessions. It's just about 1 hour 41 minutes or thereabouts.
In orchestrating.
Okay? And bear in mind that this is still the first week. This is week one. They just started. Now, the first week they did the seed and start approach. So seed approach is talking about how do you introduce yourself when you go for an interview? How do you introduce yourself? Okay, so you talk about your skills, your experience, your achievement, and your trait. And these are the things that we bring in people to come and teach you. How have they been successful in their own interview process? Okay, and what has worked for them? So there's a popular saying that says, "Follow who no road." Okay, follow who no road, and that's exactly what we're trying to do. So we bring people that have experience in doing it, and people that have failed, bring them in to tell you why you shouldn't fail and how you can also succeed without failing. So you see the live class, data cleaning Excel live class, you have the recording. Every session is recorded and you have lifetime access to the recording. Okay. And also you have lifetime access to the LMS. All right. You have lifetime access to the LMS and you have lifetime access to the recording. So you see double-edged sword. That's why I say when we say blended training delivery, you're in the right place. Okay. So every case study, every live class is a case study. All right. Every live class is a case study. All right. Now let's take a look at the live class, the material. You see data cleaning with Excel. So you start with data cleaning. You see data preprocessing, all the things that we talked about that we had to do today. You will start to do it from Excel. You go to Tableau to do it before you now enter into Python. So you have a very huge scope around data preprocessing. And that's exactly what you will get to work with. So that's exactly what we've talked about, okay, in today's session. Okay, so you have a lot of things, at your beck and call. You have materials, you have self-paced, you have live classes, you have a community and everything. So the training program is for 3 months. Okay, so 3 months live classes, 3 months live classes. So it's for 3 months. So that's a total of 12 weeks. Okay, but normally we do 14 weeks actually with the breaks. So you're going to have breaks and all that. So we have about 14 weeks of live classes. So this is coming to live classes. And you have another 1 month free virtual internship. Okay, internship. Okay, so that's basically a total of together that will give you how many months? 4 months. Okay, so you have 3 months of learning. Okay, and 1 month of internship, which will come down to 4 months of learning. Somebody's asking also the question around, but will this have mine on Saturday evening? Yes, you can. So if you're in the UK, you are not restricted to your time zone. Okay. So if you want to have yours in the evening session, that's fantastic. That's okay. That's not a problem at all. Okay. That's literally not a problem. Yes, once you complete the training program, you get a certificate. Okay. Once you get a training program, once you complete the training program, you get a certificate. All right. So that's 4 months. 4 months of learning, 4 months of immersive learning. And see what we did today. See what we did today, just under 2 hours, okay? About 2 hours. We were able to do all that in just 2 hours. Now you understand a bit more about machine learning. You might not be able to do everything I did today, but you understand a tad bit more, okay? And that's exactly what you need to do for the next 3 months, okay? And trust me, there are tons of opportunity that you can learn, you can actually get into. Even UK, you're in US, the guys in UK, US, Canada, you guys are in for a lot. If you're looking to get a job in the US, also working remotely, let me just show you something real quick. I don't like to hide information, so you can make a decision if you want to invest in yourself or not. Okay. So these are the things that you're going to get. Okay. This is for people that want to get remote jobs real quick. I'm just going to do that. So I'm going to say data scientist. All right. So I'm not going to look at Canada. I'm not obviously this particular site is just picking my location, which is Canada. All right. I'm going to look for remote, clear all, and this remote. I just need remote, and I'm going to click on see jobs. Okay. So now these are data science jobs that are remote. Okay, that are fully remote. I'm going to remove location. Okay, and United States. I'm just going to keep it blank. So this will give you location anywhere anywhere. All right. So I'm just going to leave it blank and reset. Okay. So I'm going to say data scientist. Okay. Remote. That's what I'm going to be looking for. So you see quite a number of remote jobs in here. So data scientists at Coinbase. We all know Coinbase, the crypto platform. Okay. So Coinbase great for a data scientist, remote, and happened about 3 days ago. Salary range is about 150 to 150K basically annually. We have another data sciences role, data science. Good thing about the data science training program also is you can also work as a data analyst. So it doesn't limit you to just data science roles. You can also apply for data analyst roles. The good thing also is you could also apply for any form of analytical role. So anything that has, analytics in there, you can actually do it. Okay. So digital analyst, marketing analyst, BI analyst, data analyst, industry analyst, HRIS systems analyst, sales operations analyst, you can apply for any analytical role. So those are the things that you don't know you could do. Trust me, in ridiculously 4 months, you get a job. Those are the things that we're going to help you. We're going to show you the ropes of how you can do this. Okay. So, like we said, like I mentioned, we have a ton of testimonials that you can actually learn from. So, all you need to do is, if you want to see more testimonials of people that have gone through our training program and then gotten a job, all you need to do is go on YouTube, search for Analytics. Okay. All right. I can't play everything for you for the limited time that we have together. So once you get to Analytics channel, go to playlist, right? And you will see testimonial. You see testimonial is in there. Click on that. And we have loads of people that have gotten jobs in different parts of the world, right? People have gotten jobs literally anywhere across the world. All right. So,
hi everyone, my
let
name
me
is
let Alan
Sade
get started.
Oluwatosi. I want to talk to you about analytics today. I also did the program, that's the data science program. It's actually landed me my first tech job right here in the UK, and I do not have any previous experience. So one thing that I would really say that I like about analytics is the support that they provide. The support, it comes in terms of mentorship section. It comes in form of CV reviews and also LinkedIn optimization. I am going to recommend analytics to every Black person that I know that are interested in tech. I'm really going to recommend them to everyone that I really know. Thank you.
All right. So you see, those are the kind of testimonies you get to see from here. Okay. People that have gotten jobs in the UK, there are people that have gotten jobs in the US, in Canada, so on and so forth. And that's it. You see them here. So when we say we will get a job, you will get a job. We'll ensure that we'll still work with you till you get a job. All right. It's only if you are so relaxed or you don't want to, you're not very prone, you don't want to put yourself out there, then that's when you might have a bit of, but we will work with you, we'll push you till you get what you're looking for. All right. So you can reach out to any of these people that worked in the job, ask them about their experience, and that's it. All right. So, getting started, the discount is obviously just limited to the first 20 people to apply. So if you're looking to getting started without wasting time, this is the platform to be on. All right. So if that's why we did the master class. So the last 2 hours, see what you learned. So imagine you now spending the next 3 months immersing yourself in this environment. Trust me, you'll be the person. You'll be the person to be training other people when you get to where you want to, when you get a job. All right. So projects that you work on, projects across different industries from hospitality to e-commerce to electronics to predictions to real estate. So your case studies will cut across quite a number of things. Now, let me just read some of them for you. Future Tail Hotel Reservation case study. This is one of the case studies that you work on. So you see, the typical reason for cancellation include changes in plans, scheduling conflicts, and so on. So these people want to find out what potential customers are likely going to cancel for the hotel itself. So it's an hotel business, and they want to see what type of customers would likely cancel, so they can prepare ahead of time. So e-commerce also sales and forecasting analytics for jumbo e-commerce. So here, as a data scientist, you're tasked with developing a sales business dashboard that provides a comprehensive regional overview of the company's operations and includes a sales forecast. That's what you're going to be working on, real life case studies. Okay, and those are the things that you work on. Let's look at the real estate one real quick before we call it a day. After that, we'll call it a day. Real estate Christina Holmes. Okay, you are responsible for analyzing and preparing the data training and selecting appropriate machine learning algorithms and testing and validating the model's performance. All right. Christina Holmes aims to create a robust, trustworthy, and precise predictive model that can assist in pricing their properties and optimizing their business decision. So those are the kind of problems you are going to be working with, like actual business problems that you can go on to work on. So you also work on projects like this, computer vision projects. So you can see these are our students, you see the analytics and detection, analytics post detection, all right, and you see them play, all right, all right. So you see all the videos there. Okay. Okay, so you see all the videos there. These are all Analytics alumni, and these are the projects they've worked on. So it's very exciting to see this, isn't it? So you would also get to work on this. This is computer vision. You use your computer to detect certain object detections and all that. So you get to work there. So like I said, it always seems impossible until it is done. So the key thing, guys, join our training program starting on the 8th of June, 2024, 8th of June. So anyways, I know you guys have had a wonderful time. I'm not going to keep you any longer. This is 2 hours, 33 minutes. Okay, so I'm just going to call it a day here. All right, so if you're looking to get this started, guys, this is the best time to, so for you to join our training program. We're waiting for you to join. All right. I would also like to hear from you. What do you think about the training program for today? All right. So I think I'll just take 2 people. You can raise up your hand or you can just unmute yourself. Aisha, how was your experience for today's session?
It was great.
Great, awesome.
Yeah,
We
it
can't
was
wait to
nice.
start here. Yeah.
Yeah, I can't wait. And hopefully, I'm going to be among the, what they call it, those to testify before the end of the year, definitely.
Oh, 100%, 100%. I'll be looking out for you.
But I have a question.
Yeah, sure. Go ahead. Ask a question. Aisha, are you there? Go ahead with your question. Okay. I
Yes.
can't hear you.
Are
Okay,
you
I
typing
missed
them?
your question. I missed
Yeah,
your question. Could you
the code you were using to answer those questions. I didn't say you typing them, but you type the question, right? The next thing a code appeared, then you just run it. Is it that you already typed it somewhere and just pasted it, or what?
All right, so yes, I did that. So that's what I did. So I obviously have the code base already. So I just copied. So if I had to type it on the phone, it would likely take more time to do that. So I just
Okay.
copied and pasted it. Yeah. Well, you learn how
Okay.
to write your own code yourself, 100%.
Yeah,
Okay.
I'm not actually really into Python. I'll be using Visual Studio. But I love how you make it very simple. Python nearly
Yeah.
swallowed me before.
Don't worry, Python will swallow you. You'll be able to swallow Python now. Okay. All right. Thanks a lot, Aisha. I appreciate your time.
You're
I
welcome.
appreciate that you've also registered. Okay. Looking forward to seeing you on the 8th of June. Cheers. Now, Ike Tuku, what's happening? Are you in the kitchen?